Hi everyone, welcome to ashokit. This is Sandeep and I am going to teach you data analytics. In the next 2 to 3 hours, we'll learn how to store, manage and work with data using MySQL. Even if you are completely new to databases, don't worry, we are starting from basics. MySQL is a powerful and widely used tool that helps companies to store and to access the data quickly, right? It's used in websites, applications, and also in business tools around the world. By the end of this crash course, you'll know how to create a database and also tables, right? After that, how to insert data into database and how to query the data and also write simple SQL commands to solve real problems. Welcome to this SQL crash course using MySQL Workbench. Let's dive in and start learning. Okay, first let's understand what exactly are we going to see in this crash course. We will start with introduction to SQL. Here we'll also see some history of SQL. Okay, after that SQL commands. That means what are all the commands that we have in SQL. Data types, creating a database and tables, inserting data, and select statement. This is the most popular function in SQL, right? After that, filtering data using where clause, pattern matching operators, group by and order by, SQL functions, joins, constraints, and at last, we'll also see some interview questions based on MySQL. Um, when it comes to interview, okay, joins is one of the most important topic when it comes to interview questions on SQL. Okay, after joins, there is one more topic, that is window functions, right? Window functions is also the important topic when it comes to interviews perspective, right? So after completing all of these topics till constraints, we will see window functions also. Then we'll go on to interview questions. Okay, so let's start. So let's begin. Let us start with introduction to SQL. Okay, so we'll go a bit backward. That means when DBMS and RDBMS, we'll see what exactly is DBMS and RDBMS in some time. But before DBMS and RDBMS came into the market, right, all the data used to be stored in text files. All the data is to be, used to be stored in text files. Okay, and this concept was called FMS, nothing but file management systems. Okay, before DBMS and RDBMS came into the market, all the data used to be stored in text files. When I say text files, that is nothing but notepad or word file, right? And that concept was called FMS, file management system. Okay, where all the raw data is stored at one place. Okay, now main problem with this FMS is the data is not properly organized, right? The data was not properly organized. If we want to retrieve some data based on some condition, or if we want to apply some joins or subqueries on data, these things cannot be done in FMS since the data is not properly organized, right? That means FMS is only used to store the data, but not to do any kind of operations on it. Okay. Now, after this, after FMS, Microsoft Excel came into the market. Okay. Microsoft Excel came into the market. Using this Excel, we can perform things, but the functionality of Excel is a bit limited, right? Not 100% of the things can be done in Excel. Okay. That's why later on, we got DBMS into the market. What exactly is DBMS? Database Management Systems. Okay, DBMS, Database Management System, came into the market. This is not the tool. This is just the concept that says, yes, we can store the data in tables in hard drive. That means in local systems. Okay, where we can easily access the data, because once the data is stored in a proper structured format, that is tables, that means nothing but rows and columns, each of the cells will have address, correct? And using that address, we can easily access any part of the data and perform some operations on it. Nothing but easily accessible, correct? Because the data is in structured format. Okay. Now, again, there were some issues with this DBMS. Performance issues. Okay. Because all the data is stored in a single table. Okay. All the data here in DBMS used to be stored in a single table, right? That's why there were some performance issues where the speed to access the data is a bit higher, right? That's why later on RDBMS came into market. Okay, RDBMS, again, it's a concept. In DBMS, all the data was stored in a single table. RDBMS, which is called as relational database management systems, here the data is stored in multiple tables. That means the whole data is splitted into small, uh, parameters, we can say, right? The whole data is splitted into small groups and stored in different tables. For example, any company will never store all of those data in a single table, correct? If we take Amazon as an example, all the data related to Amazon company will never be stored in a single table, right? They'll have multiple tables. For example, there will be one table which has product details. Another table is to show sales details. Another table is to show region details or location details, for example. Okay, like this, each and every group or each and every parameter is stored in different tables. Okay, that is the difference between DBMS and RDBMS. Now, next point is, again, we have different tables in RDBMS, correct? Now, in RDBMS, we can build some relationships between these tables so that we can join the whole data and perform some operations on it. Here, what happens is, because we build some relationships between the tables, the performance issues in DBMS has been resolved. That means speed to access the data has been increased. Okay, in DBMS, the speed was very high. That means, for example, in DBMS, it is taken some 30 seconds to access the data. In RDBMS, to access the same data, it will take around 5 to 10 seconds. Okay, the performance has been improved. The efficiency has been improved in RDBMS. Okay, that is nothing but, that is about DBMS and RDBMS. Next, we have, okay, so to manage DBMS previously, we had some tools like DBase, Fox Pro, and also MS Access. These are some tools which supports this DBMS concept. Similarly, for RDBMS, we have Oracle, SQL Server, right? MS SQL Server, MySQL, right? DB2. This is, all of these are tools to, which supports RDBMS, right? Now, next thing is Oracle is the first company to introduce RDBMS. Okay, Oracle is the first company to introduce RDBMS. And the thing that we are going to learn, MySQL is a product of Oracle company. Okay, MySQL is a product of Oracle company. Similarly, MS, sorry, MS SQL was developed by Microsoft company. Similarly, DB2 is another SQL software which is developed by IBM company, right? Clear till here? Now, RDBMS also has some performance issues because uh, after internet came into existence, right? After internet came into existence, data is now like very huge. Very large amount of data has been produced day by day, right? So to manage all of this data, there were some limitations with RDBMS. That means that amount of huge data was not able to handled by RDBMS concept. Okay, but to maintain but to maintain some small to more than average amount of data by small and medium level enterprises, RDBMS is more than enough. Okay. And because there are some performance issues, later on, we have got some other tools like big data, NoSQL, and also Hadoop and similar kind of tools, right? Where these things can handle much more amount of data when compared with the RDBMS concept. Okay. So DBMS and RDBMS are concepts, and to satisfy these concepts, these kind of softwares were developed. Okay, understood. But obviously at the back end, all the companies still uses RDBMS because of cost effectiveness. Okay, right. So we by now we have understood that DBMS and RDBMS stores the data in a very structured format. Okay, very structured format, that is nothing but data in tables. Okay, now that we understood what exactly is DBMS and RDBMS, now we'll understand what exactly is a database. Okay, what is a database? In general terms, if we have to define database, it is the place to store the data. Okay, a database is a place to store the data in simple words, right? Now, next, okay, for example, if we take any software or if we take any application that will have three layers, okay, any application will have three layers. One is front end, one is medium end, one is back end. Okay, these are the three layers. In front end, this is nothing but GUI. GUI, what is GUI? Nothing but graphical user interface. Okay, front end is nothing but GUI, graphical user interface. Middle end, we will have some business logics. We'll take an example and understand these three layers, business logics. And at the back end, we will have database. Okay, for example, if we have to fill some online survey or online form, basically any of us or any user open that form in GUI and fill in all the details like name, email, phone number, and all the other details and submit the form basically, correct? Now, all the data that we have submitted is picked up by this business logic, okay? This business logic and go to database and store all the details that we have filled, okay? Now, in business logics, there will be some programs to do this operation that is nothing but to collect all this information and store at the database at the backend. Okay, these programming languages captures the data and store in backend. Okay, that is nothing but the third layer of any application. Okay, now if we have to take another example, let us understand this with one more example, that is mobile banking application. Okay, example two, mobile banking application. If we consider everyone will use mobile banking application, correct? Mobile banking application, first layer at the front end is nothing but it will ask for some login credentials, right? With the help of these login credentials, once we log in, we have to give some instructions like if we want to see our bank statement for last 6 months, okay, that instructions will be collected by this business logics and it will go to backend database and collect that information and give it back to us. Okay, that is how Any application, not only any mobile banking application, any application will work in this logic basically, in these three layers: front end, medium end, and back end. Understood? Now, next point is front end will be developed by using some scripting languages. What exactly are scripting languages? Developed by scripting languages like HTML, DHTML, XML, right? All of these are nothing but scripting languages. ASP.NET, JSP, and also Excel VBA. Okay, VBA is another most popular scripting language that is used in Excel. So front end is developed by HTML, DHTML, XML, on all of these scripting languages. And what is HTML? Nothing but hypertext markup language. Okay, HTML, hypertext markup language. Now, business logic. To develop this business logic, we'll use some programming languages like C, C++, Java, .NET, or Python. Okay, these are some programming languages that is used to build some business logics where we collect the data from the user and stores or interact with the database at the backend. Okay, now next comes our backend thing, that is database. Okay, here we'll have Oracle, MS SQL Server, MySQL, DB2, and all of the other software that we have mentioned earlier. Okay, once, I mean, one of these softwares will be installed in our local system and all the data can be stored and accessed from there. Okay, so this is how database came into the picture. This is how database came into the market. Okay, we can maintain multiple data servers or multiple data, I mean, software servers, because if the data load is more, single database software will not be able to hold that data. Okay, so in simple words, database is nothing but a place to store the data, and whenever we want, we can access the data, right? So that is about the database, and that is how it came into the market. Now that we understood what exactly is a database, now we'll understand what is SQL. Okay, SQL is nothing but structured query language. Okay, in data analytics, we only deal with structured data, right? That's why this name also came, that is structured query language. This is a query language to interact with the data, to manage the data, right? Now, why is this SQL developed basically? Okay, we as humans cannot interact with the database directly. This is the symbol of any database. We as humans cannot interact with the database directly because all the information in the database will be stored in zeros and ones, which is the binary language. For example, if we download any movie or any file from the Google or internet, that will be stored in database in zeros and ones. Will not be able to read that, will not be able to understand that, right? That's why we need a medium to interact with the data. That is SQL. Okay, in simple words, SQL is used to interact with the data. SQL is used to talk to the data. SQL is used to manage the data. Okay, when I say manage the data, nothing but manage data is nothing but accessing the data, inserting, adding, updating, or deleting, or modifying also, right? When I say manage data, all these of, I mean, all these things comes under managing the data, and SQL is used to manage the data, right? Now, SQL is developed by different companies, right? SQL Server, MS SQL, Oracle. and all of these kind of softwares were developed by different companies. But syntaxes for formulas and functions, syntaxes or content in all of these softwares is similar. Okay, syntaxes and contents in, I mean, is same across all of these applications, all of these databases, right? It's just that interface is different and owner is different. Okay, maybe 0.1% of the syntaxes might differ, but it is almost the same across all the databases, right? Now, database components. Okay, what are the database components? There are two components of any database. That is, one is server, one is client. Anyone know what is the difference between server and a client? Server is used to store the data. Okay, and client. So basically, server is a place we store the data. Now, client is a component where we execute all the queries. Execute all the queries or commands which sends requests to server, sends requests to server to access the data. Simple. Or to perform any kind of operations on data, right? Client is nothing but it's a place or it's just an editor where we write all the queries. That means sending requests to the server to access the data or to perform any kind of operations on data. Okay, right. Before executing the queries, this client should be connected to the server because that is the place where we store all the data, right? Without a proper connection, the any kind of performing operations is not possible on data. Okay, both are softwares. Both are softwares. Once we install my SQL workbench, okay, automatically a server and a client will be installed. Okay, by default, both client and server will be installed along with the my SQL workbench. Now, server needs a lot of memory because we store unlimited amount of data, right, in the server itself. Now, client, we can say this as lightweight tool. Okay, client is a lightweight tool because, like I said earlier, there will be only one editor where we write all the queries to interact with the server or interact with the data. Because we only have editor, this is a lightweight tool. This doesn't require much memory, right? One more point here is client and server need not to be installed in the same system. Okay, they can both be in different machines, but we just have to connect our client with the server to access the data. For example, in a company, there are 100 users of SQL. Okay, in all of these 100 user systems, server and both a server and client, both of them are not required to be installed. Okay, server can be installed in one system and can be accessed by any number of clients. Okay, all of these are clients which are connected to the server to access the data. Okay, understood? Right. Now, server, okay, mostly will be installed in Linux or Unix operating systems. Okay, now client will be mostly installed in Windows operating systems. Why? Because of security purpose. Security will be more in Linux and Unix when compared with the Windows operating system, right? Because the server, I mean, if we install server in Linux and Unix, the data is a bit more secured. Okay, once we lose the data, losing the data costs us very much, right? That's the reason why we store all the data in server, which is installed in Linux or Unix operating system. Now, again, after that, client will normally be used in Windows operating system. Okay, understood. Architecture is very simple. There will be one central server here, and all of the other clients can be, any number of clients can be connect to that server and use the data or access the data or modify the data basically. Okay, now when it comes to clients, there are two types of clients. Okay, one is GUI, nothing but graphical user interface. One is GUI, another one is CLI. What is CLI? Nothing but command line interface. Okay, GUI, graphical user interface, and CLI, command line interface. Now, what are the things that come under GUI? GUI, first thing, SSMS. What is SSMS? Nothing but SQL Server Management Studio. Okay, this is another software which comes under GUI. Similarly, we have MySQL Workbench. This also comes under GUI client. Another thing is PG admin. All of these are nothing but another software that comes under GUI. Also DBWare. Okay, so these kind of applications will come under GUI. Now, what exactly comes under CLI? In CLI, we have MySQL command line client. Okay, next we have PSQL. Some of you might heard this, Postgre. Okay, PostgreSQL client, right? Next we have Oracle SQL Plus. This is another client that comes under CLI. Now, what exactly is the difference between GUI and CLI? Okay, GUI and CLI. In CLI, the output will be 100% based on text. Okay, the output will be only in text format. But with GUI applications or GUI databases, the output will be both in text or charts format. Nothing but graphs. Okay, we can get the output in graphs or charts, charts format with GUI, and with CLI, the output will be only in text format. That is the only difference between GUI and CLI. Okay, understood? Now, next we'll see what are all the SQL commands we have. Okay, we have 5 types of commands like DDL, DML, DQL, TCL, and DCL. What exactly are these? DDL, nothing but data definition language. Okay, data definition language, data manipulation language, data query language. TCL is nothing but transaction control language. After that, DCL is nothing but data control language. Okay, and what are all the commands that comes under DDL? Nothing but create, alter, sorry, create, alter, drop, truncate, and there will be one more, that is rename. Okay, these are all the 5 commands that comes under DDL. Now, what exactly comes under DML? Nothing but insert, update, and delete. These 3 commands comes under DML language. Data manipulation language. Now, what exactly comes under DQL? There will be only select statement. Data query language will have only select statements. And under TCL, we have commit, rollback, and save point. Okay, these 3 commands comes under TCL. Now, what exactly DCL is? DCL, we have grant and revoke. data control language, nothing but grant and revoke functions. Mostly data control language is used by the admin team. Okay, you'll find some roles like SQL administrator, right? SQL administrators only use DCL, that is managing permissions, grant permissions or revoke the permissions. Okay, just to manage the access, SQL administrator only uses DCL commands. Now all the other roles which are like SQL developer uses all of these other commands also. Okay, understood till here? Clear till here? Now, along with these commands, we'll also have aggregate functions, joins, constraints, right? Constraints. Next, we'll also have uh, operators. There will be different types of operators. We'll see that later on. Operators. So apart from these five commands, DDL, DML, DQL, TCL, and DCL, we'll also learn aggregate functions, joins, constraints, and operators, right? Joins is the most important topic when it comes to SQL. Okay. Once you know all of these concepts that's present in this page, DDL, DML, DQL, TCL, DCL, aggregate functions, joins, constraints, and operators, SQL is done. This much is enough uh, to say that I know SQL. If you learn this one page, that is done. SQL is done. Okay. Now, these are all the SQL commands. Next, we'll see what are the data types that are present in SQL. Okay. All right. Data types. All right. Data types. There are three types of data types: numeric, text, and date data type, or date and time. Okay. Under numeric, we have tiny int. Okay. Next, small int, medium int, right? Big int. So these are nothing but integer data type. The only difference is the handling capacity. For example, in int, it goes up to 10 digits. Okay. In big int, 15 digits. And tiny int, small int, and medium int can only handle less than 10 digits. Okay. After big int, we have float. Next, double. What is float? Nothing but decimal format. What is double? Whenever there are large numbers with decimals. Okay, that is nothing but double data type, right? In almost every case, we go for int data type when it comes to integers or the whole numbers basically. So these are all the numeric data types that are present. Next, when it comes to text, we have char, varchar, blob, medium text. Next is medium blob. Next is long text. After that, long blob. Okay. I think we know what is char and what is varchar. Character is nothing but fixed length. Varchar is variable length of characters. Now, apart from varchar and char, we have five other types of data types in text format. These are used in complex situations. If the data is in files, example, text file, we can directly put that file into a table using these kind of data types. Okay. Not only files, also images, audio, and video, etc. Okay. That is text data type. Here, when it comes to date and time, we have date in year, month, and day format. Okay. Year, YYYY, month, MM, and DD, day format. Okay. Next, date and time format. Nothing but which is the combination of date and time. YYYY, MM, DD. Along with this, we will have hours, minutes, and seconds also. SS seconds, MM minutes, HH means hours. Okay. Next, only time data type. Nothing but hours, minutes, and seconds. First is date, second is date and time, which is a combination of date and time. Third is normal data, time data type. Next, we also have timestamp. Okay. Again, in timestamp, this is a combination of date and time. Okay. So these are all the data types that we have in MySQL. Okay. All right. So next we will talk about operators and how to create database and tables. All right. So stay tuned. The basic introduction to SQL and all the SQL commands and all the data types. Now we'll go and see how to create a database, tables, and insert the data into database, and how to use select statement, and after that filtering data with where clause. Okay. Now after that we'll see pattern matching operators also. So let's go to MySQL workbench and see all of these things. Now all right. So whenever we open MySQL Workbench, the interface looks like this. Once we connect to the local host, the option will be seen here. If you just double click on it to open, you'll get to see the actual interface of MySQL Workbench. On the left side, if you observe, there are two options here, administration and schemas. In administration, we'll get to see what is the server status, is it active or not active, along with all the other options. In schemas, we'll be able to see the databases that are present inside our system. Okay, by default, we'll get one database, that is sys, right? Now, this area in the middle is called an editor. This is the place where we write all the queries and execute them. If you see, there is a lightning symbol here. This is the run button. This is the button to execute all the queries that we write. Below it, we have output. Okay. Action output. That means whenever we write some queries, whether it has some errors or not, right? That status will be visible here. Okay. Now, obviously above it, we'll have an output window once we execute the queries. Now, if you see, there are some other options also. We'll explore this later. But the first thing that you see here, a small icon, that is SQL icon, along with the plus symbol on it. Okay. This is to create a new SQL tab for executing queries. Okay. If we just click on it, you'll see as I go and clicking on it, you'll see more tabs are getting inserted here. Okay. This is same like sheets in Excel and pages in Power BI. All right. So let me just close all of this. So this is the basic interface, how actually MySQL Workbench look like. Now, first thing we'll see is how to create a database, right? To create a database, I'll just use this simple statement, that is create database. Okay, this is the syntax that we need to follow, create database. And after that, we need to just specify the database name that we want to create. Okay, for example, I am just creating school DB. This is the name of the database that we want to create. Okay. Now I'll just execute this one line. If you observe, the status shows the green icon. That means there are no errors in this query that we have just written. Okay. Now, once we create the database, that should appear on the schemas tab here, right? If we just refresh this is a refresh button. If we just refresh this, you'll get to see school DB. That is the database name that we have just created. Okay. Now, next thing that we want to do is how to create tables inside this database. Now, if you just expand this database, you'll get to see these options: tables, views, stored procedures, and functions. There is no another drop down for this tables, right? There is no expanding option for these tables. Once we create the tables, then you will get to see what are all the tables that's present in the in this database, along with the column names, right? For that, We'll just create a table and see. Okay. Before creating table, there are two databases as of now, right? One is SIS, one is school database. Now we need to mention where exactly do we want to create some tables? In which database do we want to create some tables? Okay. For that, I'll just write this as to specify the database to use. Okay, that means in which database exactly are we creating some tables. For that, I'll just write the query as use. Okay, and directly we can just mention the database name, school DB. Okay, if we just execute this, the status shows success. That means whatever tables that we create from now, that will be stored in the school database. Okay, now to create a table. Okay, how to create a table? The query is, if you observe, I'm just specifying the comments here. Okay, this code of lines will not be executed by this software. Now, to create a table, I'll just write the query as create table. Similar to the create database and then giving database name, here also create table and then you give the table name. For example, I want to create table name as students. Okay, students is my table name. After that, open brackets. I can just directly mention all the columns that we want inside our table. For example, I want student ID column. After that, name column, age column, grade column, for example. Okay, this is how we can mention the columns directly. Okay. Now, if you observe, this is showing a small cross icon here. That means there is some error in the query that we have written. If we just directly execute this, you'll definitely get an error because for each and every column, we also need to mention the data type of it. Okay. For example, student ID, which only consists of integers. Okay. I'll just mention the int data type here beside student ID. Okay, student ID, int, name, which is a text data type. I'll just use varchar. And inside this varchar, I'll just write it as 50. That means name column should contain all the names which should not exceed 50 characters. Okay, that is the meaning of varchar of 50. Now next age is also again int. For grade, I'll just use char data type. Char of 1. That means in grade column, that should contain only one single character. Grades normally are like A grade, B grade, C grade, right? Because that is only single character, I'll just write it as 1 here. Okay. If we just execute this, the status is success. And if you just refresh this, you'll get to see tables has a drop down now and we have a students table. Okay, if you still expand this, you'll get to see all the columns that are present in our table. That is student ID, name, age, and grade, right? Now, if I just use, if I just want to see the structure of the table for each and every column, what is the data type that we have used? Okay, I'll use I'll use different function that is to check the structure of the table. Okay, I'll use describe function here. Describe, I can just directly give the table name, describe students. Okay, if we just execute this, we'll see the output. You'll see all the fields and type of that field. Field is nothing but all the columns, right? And type is nothing but the data type. Okay, you'll see all these kind of details using describe function. Now, next thing I want to do is insert some values into the table that we have created. Okay, inserting some values into the table. For that, the query, I'll just write it as insert into. This is the syntax that we need to use. Insert into. I can just directly mention the table name inside insert into students. After that, column names we need to give student ID, comma name, comma age, comma grade. These are all the column names, right? After that, I'll just write it as values. Inside this values, I can just directly give the values or the records. For example, first record, I'll just mention it as 1, comma, Arav is a student name, for example, age 14 and grade A. If you observe, there is a small difference between these four values here. For numeric values, we can just directly mention it like this, right? But whenever we use some text values, we need to enclose that in the double quotes or single quotes. Okay, now I'll just use comma here, comma. I can just directly enter the second record, that is student ID 2, name, some other different name. Okay, for example, Ravi. After that, age 15, grade B. I can mention it like this. We'll insert some two more values, two more records. For that, third record, Sita, age uh, 13, for example. Okay. Now grade is again A. Okay. Next record, comma, for student ID, name, Mira, for example, age 15 or whatever it might be 16. Okay. Next grade is C, for example. Okay, we have inserted four values like this. If we just execute this line of query, the status shows unknown column student ID. Okay, there is a spelling mistake here. Student ID. Okay, now if we just execute this, the status shows success and all the four values got inserted into the table that we have mentioned here. Now, how to check, okay, how to retrieve what is the data that's present in our table? Here we only have four values, right? We obviously know that these are all the values. For example, we have some hundreds of records, some thousands of records, and to see all the content or retrieve all the content in the table, we'll use select statement. Okay, select statement. How to use this? I'll just write the query as select star from table name, that is students table. Okay, why exactly are we using star? This star represents the whole table, each and every record, each and every column. Okay, select each and every column and each and every record, each and every value from students table. Okay, I'll just execute this. You'll get to see what are all the values that we have inserted into the table. Okay, for each and every column. All right. Now, for example, if we don't want to show all the four columns, I want to just see the two columns, which is name and age. Okay. I'll just write the query as select name, comma, age. Previously, we have given star symbol, which represents the whole table. Right now, I am just mentioning it as select name, comma, age from students table, students, students, students table. If we just execute this, you'll get to see only two columns. Previously, it was showing all the columns that are present in the table. Now it is just showing only two columns that we have specified here. Okay. All right. So we'll just execute this select star from students again to see the whole content. Okay. Now this is how to retrieve the data from the table using select statement. Now next is where clause. Where clause is used to filter the data. Okay, where clause is used to filter the data. For example, we want to retrieve all the students who are older than 14. Okay, if you observe in the table, there are only two records where the age is greater than 14, right? Now to retrieve these values only, I'll just write it as select star from students. Okay, students. I'll use where clause here, where age is greater than 14. We can just directly mention it like this. Select star from students where age is greater than 14. If we just execute this, you will get only those records where age is greater than 14. There are only two records. For example, if we use greater than or equal to here, okay, now we should get three records, right? Where the age is either equal to 14 or greater than 14. If we just execute this, you'll get to see three records. Understood? Clear till here? Now, for example, we want to get only the student names whose grade is equal to A. Okay. Now the statement, the query will be select name, only the name column and age column whose name column and grade column whose grade is equal to A. For that, select name, comma, grade from students table where grade is equal to A. Okay, I'll just execute this query. We'll get to see only two columns, that is name and grade is equal to A. This is the condition that we want, right? If you observe, there are only two columns, name and grade. And in grade, if you observe, the values are only equal to A, right? Now, this is how we use where clause. Okay. Next, along with the where clause, there are some operators. Okay. Operators, when I say, that is logical operators. We have logical operators, that is and, or, not. Okay, these three are the logical operators that we'll use now along with the where clause. For example, where clause, till now we are just specifying a single condition here, right? Now, for example, we want to work with multiple conditions. We can use and, or not operators like this. For example, we want to get the names of the students who, whose age is greater than 14 and also grade is equal to A. For example, this is a problem statement. All right. Now the query for this will be select name, age, grade, okay, from students table where age is greater than 14. I'll use and operator here along with the where clause. First specify one condition and we can directly mention the another condition, that is grade is equal to A. Okay, again, like I said, numbers don't need to be enclosed with double quotes or single quotes, but whenever we write some text, that should be enclosed with double quotes or single quotes. Now, if we just execute this, you'll get to see there are no records. That means there are no records in the table which satisfies these two conditions. For example, if I just change this 14 to 15, no, there won't be any values again. For example, if I change this greater than to equal to symbol, okay, equal to 15 and grade is equal to A. There are no values again. Age greater than 13. Let's check this. Okay, if you observe, there is one record where both of these conditions are satisfied. First, age greater than 13 satisfied, and along with that, grade should be equal to A. Okay, by this, what did we understand? That means to perform this AND operator, both of these conditions should be satisfied. If either one of these conditions are not satisfied, this will not give the output. Okay. Now, for example, next we want to get names whose age is greater than 13 or grade equal to C, for example. Now, okay. Now the query will be, here we have used AND operator, right? Where it checks if both of the conditions are satisfied, then only it will give a output. Okay, now by using OR operator, either of the conditions should be true. Okay, that means I'll just write the query as select star from students, okay, where age is greater than 13 or, okay, let's take greater than 14. Okay, age greater than 14 or grade equal to C. Okay, if we just execute this, this will show all the records. Either the age is greater than 14 or grade is equal to C. Okay, that's how we use OR operator. Next is not operator. Not operator. Okay, not operator just gives exactly the opposite of the output. Okay, for example, I'll just write the query as select star from table name where age, sorry, where, okay, not age is equal to 13, for example. Okay, the expected output is all the records whose age is not equal to 13. We'll just execute this. You'll observe there are three records whose age is not equal to 13. If you observe all the three records, age is either 14 or 15 or 16, but exactly not equal to 13. Okay, this is how we use where clause with logical operators. Okay, next we'll see we have pattern matching operators. Okay, in this pattern matching operators, we have two things. One is like and one is not like. Okay, we use this pattern matching operators, which is otherwise called as wildcard characters. Okay, wildcard characters, we have two things, like and not like. Okay, we'll see some examples. For example, we want to retrieve only student names who starts with letter A. Okay, student names which starts with A. Okay, the query for this will be select star from table name. Okay, I'll use where clause here, where name, like, in the double quotes, we just have to give it like this, A percentile. Okay, that means any name that should start with A. That is the meaning of this A percentile. That means after A, there can be any number of characters. Okay, if we just execute this, we'll get all the records whose names starts with A letter, right? That is how we use like operator along with the percentile symbol. Now, for example, we want to get all the student names whose names ends with the letter A. Okay, ends with A. The query will be like this. Select star from students table where name, like. Now I'll just write it like this, percentile A. That means last letter should be A. Okay, double quotes. If we just execute this, you'll get to see all the names whose name ends with the letter A, right? Now, for example, uh, next example, we want to get all the names where second letter is A. Okay, all the student names whose second letter is A. For this, I'll just write the query as select star from students where name, like, in the double quotes, I'll just mention it as underscore A percentile. Okay, what does this exactly mean? That means first letter can be anything, second letter should be A, and after that, after A, there can be any number of characters. That is the meaning of percentile symbol, right? If we just execute this, you'll get to see all the names, all the records where there is the A in the second letter, second character, right? Now, for example, we want to retrieve all the records where the names with exactly 5 characters. Okay, the query will be select star from students where name, like, here I can just directly give 5 underscores. Okay, 5 underscores. That means the name should exactly contain 5 characters. If you just execute this, you'll get to see only 2 records. That means in both of these names, there are only 5 characters. Okay, now this is how we use like operator. Okay, sorry, like wildcard. Now next we have not like. For example, we uh, for example, we want to retrieve all the students whose name don't end with A. Okay, all the student name who does not ends with the letter A. For this, the query will be select star from students table where name, where name. Now I'll use not like function. Previously we have used like, now we are using not like function. Now similarly, I can just directly give as percentile A. Okay, that means the last letter is A. If we just execute this, you'll get to see all the names of the students which does not ends with A. Okay, now this is how we use like and not like operator. And these are all the pattern matching operators, or these are also called as wildcard characters. Okay, so that's it for this video. Thank you so much. So till now we have seen creating a database, creating tables, inserting data into database or tables. After that, we have seen select statement. We have also seen filtering data with where clause. Then we have also seen pattern matching operators. Now, what exactly are these pattern matching operators? Nothing but like and not like. Okay, we'll use these both along with percentile symbol, right? So now we'll understand group by and order by. Okay, these both are called clauses. We'll understand each one of them. Let's go here, for example. Okay, first, group by. What exactly is a group by clause? Group by clause is used to group the rows that have same values in a specific column into summary rows. Okay, I'll just write the definition here. Used to group rows that have same values, right, in specified column, okay, into summary rows. Okay, another point is whenever we use this group by clause, we'll use this along with some aggregate function. Now what is this aggregate function? Nothing but sum, average, count, or maximum or minimum. Okay, so whenever we use group by clause, any one of these aggregate functions will be used. Okay, so now let's go back to MySQL workbench and see this group by clause with some examples. Okay, so it should be, by now it should be clear till here, not like and like pattern matching operators. So now we'll just insert one more editor and create a database again. So I'll just write this as create database and I'll just name it as employee. Okay, execute this, refresh this, you'll get to see employee. Okay, now let's use employee and create a table also. Create table. I'll just name my table as sales. In this sales table, we need to specify the column headers, right? First column will be employee ID. Data type will be int. After that, I'll just write this as primary key. Now, what exactly is a primary key? So for whichever column, if we mention primary key, that means in this particularly specified column, we cannot have any duplicate values. Each of these records will be uniquely identified. That is the exact meaning of primary key. In our example, we have mentioned this primary key for employee ID, right? So in this employee ID column, we cannot have any duplicate values. That is the exact meaning of primary key. Now my second column will be employee name, data type varchar of 50. Next, product column, data type varchar of 50. Next, quantity column, data type will be int for this. Next, sale date column, data type will be date. Okay. Now if we just execute this, successful. Now again, if we just refresh this, in tables, you'll be able to see sales table, and in columns, we'll be able to see all the columns that we have mentioned here. Okay. Now let us insert some values into this table. Okay. I have a small code here for the values to be entered. I have 50 values. I'll just copy this, paste it here. Okay. We are just entering some values into the table that we have created. We need to change the table name to sales only. Okay. Now execute, successful. I'll just show you the content with select star from sales. That is this table name. We just execute this. You'll be able to see all the records that we have inside this table that we have created. Now, let's understand this group by function with some examples. First example, if we want to find um, total quantity, total quantity sold by each employee, right? Right. For this, the query will be select employee name, and aggregate function that we use here is sum, because we want total quantity, right? Sum of quantity, okay, and show the newly created column as total quantity, okay, from sales table, and we will just group by employee name. Okay, this query will give us the total quantity sold by each employee. In this table, if you observe, there is employee name column and also quantity column. We are just using group by function to find total quantity sold by each column. I'll just select this and execute this. You'll be able to see employee names and total quantity that they sold, right? Now, another example. If we just want to find count of sales per product, okay, count of sales per product. Now we'll write the query as select product comma count of star, okay, count of star that counts all the records in the table and show the number as number of sales. Okay, new column name is the number of sales. Like in previous example, the new column name that we have created is total quantity, right? This is the sum of total quantity, sum of quantities, right? Now here same like that, the newly created column name will be number of sales. Okay, now from sales table group by product. Okay, because we are finding count of sales per product, right? Group P. Okay. Now, if we just execute this, you will be seeing there are four products: mobile, laptop, tablet, and TV, and number of sales for each of that product. Okay. Now, next example. For example, we want to find average quantity sold per product. Okay. How do we write the query? Select product. Now I'll use the average aggregate function. Okay. average of quantity, and show the newly created column as average quantity from sales table group by product. Okay, this is a query to find average quantity sold per product. Okay, I'll just execute this. Now you'll be able to see the average quantity for each of the product. Okay, now, so what is the use case for this? For the first example, we have seen that, we have calculated the total quantity sold by each employee, right? Now, what exactly is the use case? This is used to see who is performing better in time in terms of quantity sold, right? By using this example, we can find or we can see which employee is performing better in terms of quantity sold, right? And for the second example, the use case will be, this is count of sales per product. Use cases, we can identify which product are being sold more frequently. Okay. And for the third one, average quantity sold per product, the use case might be, we have to understand how much quantity is sold on average per sale of each product. Okay. That is the use case for this one. Next example, we want to find maximum quantity sold by each employee. Okay. For this, our query will be select employee name and aggregate function will be maximum of quantity. Okay. And show the newly created column name as maximum quantity sold. Okay. From sales table grouped by employee name. Okay. This is the query to show maximum quantity sold by each employee. If you just execute this, you'll get to see the employee name and maximum quantity sold for each employee. Okay. Now we'll see one more example. Okay. We want to find total quantity sold per day. Okay. We have date column, right? Now to find total quantity sold per day, the query will be select date column, sale date, and I'll use aggregate sum function here on quantity column. Okay, sum of quantity, and show this as total quantity from sales. Okay, this is a table name, and now we'll just group by sale date. Okay, this is the query to give total quantity sold per day. If we just execute this, you'll get to see per each day what is the total quantity sold. All right, now, so that is about the group by function. Next we have order by. Okay, order by the name itself we can understand why exactly do we use this order by. To just sort things, to just sort the values either in ascending order or descending order, right? Again, we'll use, we can use any aggregate function also along with this order by aggregate function also, right? So let's go back to my SQL workbench and see some examples. Okay, now from here, order by. Okay, first example, if we just want to list all sales, okay, in ascending order of quantity. Okay, for this the query will be select star from sales. I can just directly write it as order by quantity in ascending order. So this is the syntax of how to use order by function. We can just directly write select star from sales order by column name, and we should specify which is the order. ascending or descending. If we just select this and execute, you'll get to see all the details and quantity column especially sorted in ascending order. That means, and in the top rows we'll see the small numbers, and if we just go down, you will be seeing quantity will be increasing, right? 2, now it will be 3, after that 4. Understood this? Now if we just change this ascending to descending, for example, okay, now you'll observe that the quantity column is sorted in descending order. That means in the top rows, it will show the highest quantity sold, right? So this is the first example. Next example, if we just want to list all the sales with latest date first. That means we are sorting date column in descending order. Okay, the query will be select star from sales order by. Okay, directly select star from sales order by. Date column name is sale underscore date in descending order. Okay, this is the query to show all the list of sales with latest date first, right? If you observe in the sale date column, the dates are in now descending order. Okay, next example, um, list employees sales in alphabetical order by employee name, right? And then quantity in descending order. Okay. Now for this, the query will be select employee name, comma, product, comma, quantity, comma, not comma, from sales order by employee name in ascending order, because we need to get in alphabetical order, right? In ascending order, comma, quantity in descending order. Okay, we are just specifying two conditions in the order by function. Okay, if we just select this and execute, we'll get to see all the employee names starting from A till Z if there are any. And the quantity column, if you observe, the values are 2, 1, 2, 1, 1. They are not sorted in descending order, aren't they? Right? No, they are sorted in descending order because, okay, for example, okay, we are just ordering employee name in ascending order. That means all the employee names will be sorted in ascending order, starting from A letter, right? Now, for example, we have duplicate values in the employee name. That is, Alice is repeated thrice. Okay, 3 records for Alice. And inside these 3 records of Alice, the quantity will be sorted in descending order. Okay, understand this? First, we are just sorting this employee name in ascending order. And after that, we are taking quantity column and sorting them in descending order. That means if we have duplicate values in the employee name, and for each of that employee, the quantity will be sorted in descending order. Okay, right? All right. So next example, if we want to show only top 5 highest uh, quantity sales. Okay, top 5 highest quantity sales. I'll just write the query as select star from sales table order by quantity in descending order. And here I'll just use another small function, that is limit. Okay, limit is the function to show only top 5 rows. Okay, if I just execute, this will only show 5 records in the table, because we are just limiting the responses from the table to 5. Now, if I just mention this as limit 10. Now this will show top 10 records. Okay, there will be only 10 records that's present in the output table. Understood? Clear till here? Now, one last example we'll see. Now here we'll just combine group by and order by. Okay, combining group by and order by. We'll just write the query as select product, and I'll use aggregate function as count. Okay, count of star, that means we are counting the whole table, all the records in the table, and show the newly created column name as total sales from sales table. First, I'll just group it by product. Okay, after grouping, I'll also use order by clause here, group by product and order by um, total sales, because that is a newly created column, total sales in descending order, for example. Okay, now this is the combination of group by and order by. If you just execute this, you will see first all the products are grouped, right? Because we are using group by along with the product. Next, order the total sales, that is a newly created column, ordered by descending order. Okay, grouped the products, and we are just finding total sales, okay, and sorting that in descending order. Understood this combination of group by and order by? All right. So that's it for now. We'll continue in the next class. Now we'll see functions in MySQL. Okay. While learning about group by and order by, we have seen aggregate functions, right? Which can be used along with the group by and order by. And what are all these aggregate functions? Sum, average, count, maximum, and minimum. Correct? Now, apart from these aggregate functions, there are some other functions also in MySQL. Now let's go to MySQL Workbench and see those things with examples. Okay. All right. So first I'll just add one more query editor. Here, let us begin with string functions. String functions. Okay. Now, first function in the string functions is upper. And what exactly does this upper function do? This converts a string to uppercase letters. Okay. That means whatever might be the, if we have the combination of uppercase letters, that means capital letters and small letters in a string. Now this upper function converts all of them into capital letters only. Okay. For example, let us see select employee underscore name. After that, I'll just use upper function. Inside this, I'll use employee underscore name. Okay. And I'll name this newly created column as uppercase. Okay. From sales. Understood this query? Now, if you just execute this, you'll be able to see two columns, that is employee name and uppercase employee names. That means previously this is the original column, right? Employee name, where it consists of capital letters and combination of small letters also, right? In the newly created column, with the help of this upper function, we have converted all those characters into uppercase letters, right? Similar to upper, we have lower. This converts a string to all lowercase letters. Okay, for example, same thing, select employee underscore name, comma. Now I'll use lower function employee underscore name, okay, as lower case from sales. Okay. If you execute this, you will be able to see all those letters are now converted into lowercase, that is small letters, right? So that is upper and lower. Next we have concat. Okay, concatenation, nothing but joining strings. This combines two or more strings, right? So how to use this? We'll just write this as select, for example, employee name, product, and now I'll just combine employee name and product columns using this concat function. Concat, inside this, I'll have to give again employee name and product. Okay. Now the new column name, I'll just write this as concatenate, right? From sales. Now you will see three columns. One is original employee name, second column is original product name, and third column is combination of employee name and product column. If you just execute this, you'll be seeing three columns. Okay, understood this? Employee name, product, all the products are smartwatches, and this third column is the combination of employee name and product column. Okay, right. So next we have length function, which retrieves length of the string. Okay, for example, we want to find how many characters are there in employee name column. Okay, one more thing here in the concatenate, we can also add some words here. For example, we are concatenating employee name and product. In between them, we can add like this, sold. Okay, sold is the just normal word I'm using in between employee name and product. If we just execute this, you'll find that Alice sold smartwatch. Bob sold smartwatch. It is just that I'm just adding one new word between these two columns. Okay, that is concatenate. Now length, select employee name, and I'll just write it as length of employee underscore name. Okay, and show this as length of name from sales. Okay, if we just execute this, a new column will be created which shows the length of each value in the employee name, right? Next, after length, we have some date functions. Okay, first function is now. This returns the current date and time. Okay, how to use this? I'll just write this as select now, okay, as current date time. Okay, if you just execute this query, you will be able to see the current system's time and date. That is, today is 13th April 2025 and time is 20:57:44. That means 8:57:44 is the seconds, right? Now, next is cur date, nothing but current date. Okay, this extracts or only gives the date. Okay, with the help of now function, we will get date and as well as time. But with the help of this current date function, we'll get only date. How to write this? Select cur date, that is current date, open and close brackets as current date only. Okay, if you just execute this, you'll get to see only the date, right? Next, we have date function. Okay, this extracts the date part from the date or date time expressions. Okay. For example, using now, we got date and as well as time, correct? Now from that now function, we'll only have to extract the date. How is that done? I'll just show you. We can write the query as select date function, and inside this, I'll use now function. Okay, as current date. If we just execute this, you'll get to see the current date, which is extracted from now function. Okay, next we have year function, which shows only the year from the selected date. Okay, how to use this? Select year from sale date column and show this as year of sale from sales table. Okay, if we just execute this, you'll get to see for each of the row or for each of the record, you'll get to see only the year of sale. Okay, that is year function. Next we have month function. Similar to year, month function extracts only month uh, from the date selected. Okay, how to use? Select month from sale date and show this as month number from sales. Okay, now if we just execute this, you'll get to see all the month numbers which are present in the sale date column, right? Now, next after month, we have some, after month, we have one mathematical function, okay? That is mod. Now, this returns the remainder of the division, okay? And how is it used? Select mod of quantity column, if I take it as an example, divide by 2, okay? And the result show as reminder from sales. That means each and every value in the quantity column will be divided by 2, and whatever we get as a reminder, that will be shown. If we just execute this, you'll get to see the reminder. Okay, and I'll just show the quantity also, then you'll be able to understand easily. We just select this and execute. Now these are all the values that are present in the quantity column. Now we are just dividing each of this value by 2. That means we are getting this as a reminder, right? So that is how we use mod function. Okay, next. After this, we have conditional functions. And inside this conditional functions, we have if and case when function. Okay, first we'll talk about if function. Okay, if condition checks or returns a value if that condition is true and returns another value if that condition is false. Okay, how to write this? I'll just write it as select employee name, comma, if we are just checking if the quantity is greater than, for example, 2 or not. If quantity is greater than 2, my output should be high quantity, or else my output should be low quantity. Okay, and show this as sale type, for example. Okay, from sales. So this is how we use if condition. Here I'll also include quantity, comma. Okay, now if we just select this and execute, you'll be able to see employee name, quantity, and sale type. That means if this condition is true, then it should return high quantity, and if this condition is false, then it return low quantity. For example, if we see this Charlie, the quantity is 200. That means the quantity is greater than 2. This condition is satisfied. The output should be high quantity. So for wherever the values is less than 2, the output will be low quantity, right? So this is how we use if condition. Next we have case when condition. Okay, what exactly does this case when do? This provides a way to handle conditional logics. How? We'll just see. Okay. For example, same example as if condition, I'll just write it as select employee name, comma, case. We are just starting the case condition, case when, okay, when quantity is greater than 2, then my output should be high quantity. Okay. Next, when quantity is less than 2, then my output should be low quantity. Okay. After this, we can also write else. That means if both of these conditions are not satisfied, the output should be unknown. Okay. This is just for example, unknown. Next, we have to end the case statement and show this newly created column as sale category, for example. Okay. From sales. If we just execute this whole thing, you'll get to see sales category column is created, and wherever I'll also include the quantity here. Okay, right. So employee name, quantity, and wherever the quantity is greater than 2, that returns high quantity as output. Wherever the quantity is less than 2, that returns low quantity. And wherever there is quantity is equal to 2, right? Equal to 2, it is showing unknown. Why? Because we didn't specify that condition, right? Wherever the quantity is equal to 2, greater than or equal to or less than or equal to 2, I mean, we did not include that equal to symbol in any of this condition, right? So for example, here itself, we just write this as quantity is greater than or equal to 2. Now, if we execute this, you'll never see unknown as output, right? So because if the value is greater than or equal to 2, the output will be higher quantity. Okay. And this is how we use case and when statement. Okay. Next, we have group concat. Okay. Group concat. This is used to concatenate values from multiple rows. Okay. How? Let's check it out. Select. I'll just directly write it as group concat. Okay. Here I'll just give employee name, the column, and show this newly created column as um, employees, for example, from sales table. Now guess the output. This will return all the employee names as a single record. Okay. If you just execute this, you'll see all the employee names will be added in a single cell, single record, right? That is the group concatenate, right? Understood till here? Next is null function. I mean, null functions. Okay. Inside this null functions, we only have is null. Is null function. What does this exactly do? This checks if a value is null or not. How? Let's write the query as select employee name and is null of quantity. Okay, that means we are just checking if any value in the quantity column is null or not. If there is any null value in the quantity column, that will return 1 as output. If there are no null values, if there is any particular integer or decimal number in the quantity column, this returns 0 as output. That is basically 0 means false, 1 means true. Okay, now we'll just execute this. Is null of quantity and show this as is quantity null. This is the new column name that we are creating from sales. If we just execute this, you'll find one new column is added. Here we'll also add quantity. Now if you just execute, you'll observe that wherever there is a null value in the quantity column, this column returns 1. Because we don't have any null values in the quantity column, everything is 0. Right? Basically, this is true or false. Okay. Now, this is the end of, these are all the other functions other than aggregate functions that are present in MySQL. Next, we will see alter, modify, okay, update, drop, truncate, delete, and what else do we have? Rename. Okay, we'll see all of these commands. First, we will talk about alter, right? Alter command is used to modify, right, the structure of an existing table. Okay, this can include adding new columns. Okay, adding new columns, modifying the okay, adding new columns or modifying or deleting columns. Okay, so for example, we want to add a new column to the table. How do we do this? We'll just write this as alter table, table name, that is sales. Till now we only have 5 columns in our table, right? What are they? Employee ID, employee name, product, quantity, and sale date. Right? These are the 5 columns. If you want to add another column, that is region column. Okay. How do we add that? Alter table, table name. We'll just write this as add column. Okay. Here we can directly mention the column name that we want to add, region, and data type, varchar of 50, for example. Okay. This is how we add a new column into our table. If we just execute this, the query got successful. And now if we write select star from sales output, you'll see that a new region column is added with all the null values. Okay. If we want to add some values here in the region column, we can also add by using update. Okay. Now, next we'll see how to modify a column. That means modifying a column is used to modify the data type, okay, data type or properties of an existing column. Okay, how to do that? I'll just write this as alter table, table name. After that, modify column quantity, for example, modify column quantity and change from int to decimal. Okay, previously the quantity column we had is in the integer data type. Now we are trying to change that integer to decimal. Okay, we can just directly write here decimal of 12,2 or whatever it might be. Okay, we'll just execute this. Now success. Now if we just write describe sales, Okay, if you execute this, you'll find the quantity column. Previously it was int, now it is changed to decimal 12 comma 2. Okay, this is how we change or modify the data type of a column, right? Next, we have drop, truncate, and delete. Okay, now what exactly is the difference between drop, truncate, and delete? We'll just go to the PPT once. Here we will understand first the exact difference between drop, truncate, and delete. Okay, all right. First, drop, truncate, and delete. All these three functions are used to delete the values from the table or to delete the whole table at once, right? But what exactly is the difference between them? First, drop. This completely, using drop, the complete data table, okay, can be deleted, okay? And by using truncate, data will be deleted, okay? But the structure of table will stay or will remain as it is. That means if we want to add some new values in the deleted values place, we can add later on, okay? And this is the permanent deletion, okay? Now, using this delete command, this removes all the data from the table, but on temporary basis, okay? That means we have one more function in TCL functions, right? That is rollback, correct? Once we delete the content using this delete command, and by using rollback, we can get back the data that we have deleted. But that is not possible in the truncate because this is the permanent deletion and this is the temporary deletion, right? Understood the difference between drop, truncate, and delete? Now here, I can just write it as rollback command can bring the data back. Okay. But in the truncate or drop, we cannot get our data back. This is the basic difference between drop, truncate, and delete. Now let's go to MySQL Workbench. First, we'll talk about drop a column. Drop a column. Okay. Now, this again is used to remove, okay, used to remove a column from a table. Okay. And we can also delete not only a column from a table, we can also delete a complete table or we can also drop a complete database. Okay. Now, how to use this? I'll just alter table sales, right? I'll just write like this, drop column region. For example, we have added region, right? There is one region column that is present in our table as of now. If we just execute this query and okay, there is a error, drop region, can check the, okay, the spelling mistake, region. Okay, now if we just execute successful, now if we go and describe the sales table, we will get to see there is no region column present. Now again, the table is, table got into original form. That is, there are only five columns. Region column is now deleted, right? This is how we use drop function to drop a column from a table. Now, if we just want to drop the entire table, right? Now we can just directly write it as drop table and mention the table name, right? Next, this is to drop the entire table. Okay. Similarly, we can also drop entire database itself. Drop database and database name. Okay. I'm not executing this because once we execute it, all of these things cannot be rolled back, right? This is to drop the entire database. All right. Now, next we will talk about truncate. Okay. How to use this? Truncate, as we already know, this is used to delete all the rows from the table. I'll write it down. Used to delete all the rows from the table, but the structure, but the schema, right? Schema, structure, both are same. Schema of the table remains intact. That means the structure will remain intact. If you want to add some other values in place of deleted values, we can do that later on, right? Now, how to do this? I'll just write as truncate table name. Okay. Now, what exactly is this doing? This command will delete all rows from the sales table, but keeps the table structure intact so that we can add new rows later, right? This will delete all the rows from the table, but structure remains same so that we can add new values later, right? So this is the truncate. Okay. Next is um, delete, right? We are left with delete command. Okay. Why is this used? Used to remove rows from a table, but unlike truncate, it allows, okay, unlike truncate, it allows you to specify, okay, understand this. This allows you to specify conditions for deleting specific rows. Okay. Now, how to use this? We can just directly write this as delete from sales. Okay, we'll try and delete one record from the sales table, right? Where, okay, we are just trying to delete one row from the sales table where employee ID is equal to 7, for example. I can just directly write this as where employee ID is equal to 7. Okay. This statement go into our table and deletes the entire row where employee ID is 7. Okay. First, let's see the table. Select star from sales. Okay. This is the output. We have 7, right? Now, if we execute this, you'll observe. Now, again, if we select star from sales, you'll see that 7 is now disappeared. 7th row, that means wherever the employee ID is 7, that entire row has been deleted now. Correct? Right? Understood this? Now that is how we delete from a table using some specific condition, right? Now, next, deleting without where clause. How to do this? For example, uh, delete all the rows from the tree. I mean, this is the definition, right? We already know this. Now, for example, I write this as delete from sales. Now, what does this query actually do, right? This commands delete all the rows from the sales table, but keeps the structure intact. Okay, right? All right. Now, after deleting everything from sales table or any other table, if we just want to bring back all the things that we have deleted, we can just use rollback function. Okay, we'll see that rollback in the coming sessions. All right. Next condition, next function we have update. Okay, update statement is used to modify the existing records in the table. Okay, this is used to modify the existing records in the table. How is this done? Let me show you. Okay, right. First thing, if we want to update a single record, right? Now, if I just write this as update sales, that is table name, and we are just setting quantity, okay, is equal to 100, where employee underscore ID is equal to 10, for example. That means wherever the employee ID is 10, we are just replacing that quantity value, whatever it might be. It might be 1, 2, 3, 4, 5, whatever it is. We are just replacing that value with 100. Okay. If we just execute this, the operation is successful. Now, if we just select star from sales, wherever there is 10, the value of quantity is now updated to 100, right? Now let's try another example. Now the 11th row, employee ID 11 has quantity as 4, correct? Now we'll update this with 400, right? I'll just write this as update sales set quantity equal to 400, where employee ID is equal to 11, right? If we just execute this, now select star from sales, you will get to see at the 11th record, this quantity number is now updated to 400. Previously it was 4, now it is updated or replaced with 400, right? Now this is how we update a single record. Now next, updating multiple columns. Okay, how to do this? I'll just write it as update sales, that is a table name, set product is equal to tablet. Okay, is equal to tablet. Okay, close the double quotes, comma, quantity is equal to 15,000, for example, 15,000, where employee ID is equal to 15. Okay, that means this goes to employee ID. This goes to the row where employee ID is equal to 15, and change the product to tablet and quantity as 15,000. If we just scroll down and see the 15th uh, ID, we have 15. Name is Olivia. Product is smartwatch. Quantity is 2. Now, if we just execute this and see the table again by select star from sales. Now let's observe the 15th row. What exactly does this tell us? 15th row, Olivia. Now previously it was smartwatch. Now it has been changed to tablet, and quantity, if you observe, previously it was 3, I guess. Now it is updated to 15,000. Okay, like this we can change multiple columns also, multiple values also at the same time. Okay, now, for example, we want to update multiple rows. Okay, I'll just if we just write this query as update sales set amount, sorry, quantity is equal to 1.1. Okay, set quantity is equal to quantity into 1.1. That means for each and every value in the quantity column, we are just increasing that by 10%. If this value is 1, we are changing that, or we are updating that value to 1.1. Okay. Now, where uh, not product, where employee name is equal to David, for example. Okay. That means wherever there is employee name David, we are just converting that quantity from 2 and increasing this by 10%. Now for David, the quantity is 2, right? Once we execute this statement, and now if we just see select star from sales, you'll observe that David, I mean, previously it was 2, now it is increased by 10% and the value has been changed to 2.20, right? Now, similarly, if we change this and write this as where sale underscore date column is less than 2024 0 1 10. Okay, that means wherever the date is less than 10th January 2024, the quantity should be multiplied by, I mean, increased by 10%. Now, if we just execute this, okay, now select the statement, you'll observe that each and every value is now being updated by 10% wherever the date is. Okay, incorrect date value 2024-0110. Okay, let's change this to 01, for example. Now select this, run this. Again, it is not showing. Why? We have given semicolon. Quantity is equal to quantity into 1.1, where sale date is, for example, let's change this less than to greater than. We just okay, still error. Why? Any error do we see here? Quantity where sales date is. Okay, let's change. Okay, there is a space in between this year and now we'll have to get that. Okay, now if we just select star from sales and see the output, okay, this shows wherever the date is greater than 1st January 2024, that sales has been multiplied or increased by 10%. Okay, this is the condition to satisfy that question, to answer that question, right? Okay, this is how we use update statement, right? After this, we have another topic. If we just go to the course content, now we have completed SQL functions. This is done. And we have also seen alter, update, delete, right? Drop, and also truncate, right? These all things we have seen. Now, before going into joins, we have another small topic, that is operators. Okay, just a second. We have another topic, that is set operators. What are these set operators? We'll see. Okay, now set operators. We have four set operators. One is union, union all, intersect, and the last one is um, this is except. Okay, intersect and except. So what exactly are these set operators? We'll first understand that. Okay, what exactly are these set operators? Just a second. Now, all right. So set operators allows you to combine. Okay, set operators allows us to combine the results from two or more queries, or we can just tell this as two or more select statements. Nothing but two or more queries, nothing but two or more tables. Okay, this allows us to combine the results from two or more tables. In simple words, we can use tables, right? First, like I said, we have four set operators. For example, we have two tables. Okay, table 1, table 2. In this, we have values as 100, 101, 102, 103, and 104. Here in table 2, we have 103, 104, 102, 105, and 106. Okay. Now, if we apply union in both of these tables, the output will contain only unique values from both tables. Now, the output will consist of all the unique values starting from 100 till 106. Okay. That means 100, 101, 102, 103, 104, 105, and 106 also. So these are all the unique values present in both the tables, right? This basically removes duplicate values. Okay, that is union. Next is union all. Okay, this returns all the values including duplicates. Okay, that means in the output we'll be able to see starting from 100, 101, 102, 103. Now what exactly is repeated? 3, 2 times 4. Okay, 102, 103, 104, 105, and also 106. Along with this, duplicates also 102, 103, and 104. So all of this values will be returned by using union all. Okay, basically this keeps the duplicates, right? That is union all. Next we have intersect. Okay, this returns only common elements in both the tables. Okay, that means in the output we'll be able to see 102, 103, and 104 because only these three values got repeated, right? Next we have except. Now this returns the rows from first table, okay, that do not exist in the second table. Okay, all the values that are present in the first table but not in the second table, right? All right. So these are nothing but set operators. And in these four set operators, MySQL only supports union and union all. Intersect and except are not supported in MySQL Workbench. Alternatively, we can get the output similar output using inner join and left join. Okay, inner join and left join. We'll see what is inner join and what is left join in the coming time. But just for your understanding, MySQL supports only union and union all. We can get the same output as intersect and except by using inner join and left join. Okay, understood? Clear till here? All right. So now we'll understand what is the syntax of all of these set operators. Okay, we'll go to MySQL workbench. All right. So now we'll understand the syntax of set operators. Okay. Now, first, union. Union. Okay. Right. Now the output will be all the unique elements from both the tables. If we have two tables or more than two tables, if we perform union operator between those tables, we'll get all the unique elements. And the syntax is select from table 1 union, this select star from table 1. Here I'm just mentioning it as table 1. You need to mention the table name, right? Union select columns from table 2. This is the syntax, right? Now, this is how we use union. Next, here also we can just, instead of columns, we can just write it as star, right? Next is union all. Okay, this union all, what exactly this returns? This returns all the values present in both the tables, including duplicates. Okay, here only unique elements. This basically removes the duplicates. Okay, here this union all operator includes the duplicates, right? And the syntax will be, we'll just write this as select column from table name, that is table 1 union all, select column from table 2, right? This is the syntax for using union all. Okay, now next, intersect. Like I said, there is no support for intersect in MySQL workbench. We'll see this when we see the joins, intersect and except. All right, so this is the end of set operators. We have seen functions. After that, all of these commands like alter, modify, update, drop, truncate, delete, correct? We have seen all of this. Now, after that, we have seen set operators, that is union, union all. Okay. Now, next we'll talk about joins. So joins. Joins is one of the most important topic in SQL, and this is the most important topic when it comes to interviews perspective also. 90% of the questions will be asked on joins. Okay, so let's understand what exactly joins are, and there are some types of joins. First, we'll understand them theoretically, then we'll go to MySQL Workbench and see some examples of joins. All right, so let's, okay, now what exactly are joins? Joins are nothing but these are used to combine the data or combine the rows from two or more tables. Okay, two or more tables based on a common column. If there is no common column between two or more tables, we cannot use joins. Okay. So that is the basic understanding of joins. Now, this is essential in relational databases where data is normalized into multiple tables and you want to retrieve related data together, right? Now, next, there are types of joins. Okay. Inner join, left join, right join, and the last one is full join. Okay. There is one more join, that is cross join and self join also. So, but mostly in almost 100% of the cases, we only use these four joins, and these two are, good to know things. All right. So let's understand each of these join separately. And one more point here is MySQL Workbench does not support this full join by default. Okay. That means we cannot execute full join in MySQL Workbench. Instead of that, we will get the same result using union and left join and right join. Okay. Using these three functions, we'll get the same output as full join only. All right. So let's understand what exactly is inner join first. Okay. Inner join only retrieves the common elements from both the tables. For example, we have a table here and the values are 1, 2, 3, 4, and 5. Okay. We have another table and the values are 1, 2, 3, 6, and 7. Okay. Now, if we just apply inner join between these two tables, in the output, we get only common elements. Okay. That means 1, 2, and 3. This is the only output that we get when we apply inner join between two tables. Clear with this? Now, next, left join. Left join retrieves the common elements, and this also retrieves all the other elements from the left table. Other elements from left table or first table. Okay. That means same example. We have 1, 2, 3, 4, and 5. Okay. Sorry. Yeah. We have. Okay. Sorry. Just a second. 1, 2, 3, 4, and 5. In the next table, we have 1, 2, 3, 6, and 7. Now, if we just apply left join between these two tables, the output will be like this. This retrieves all the common elements, that is 1, 2, 3, and this also retrieves all the other elements from the left table, that is 4 and 5. So in the output, overall, we'll get the common elements, that is 1, 2, 3, and also the other elements that is present in the left table or the first table. Okay, so this will be the output. Next, we have right join. Okay, this is the exact opposite of left join. That means this retrieves common elements plus this also retrieves all the other elements present in a right table, that is second table. Okay, understood what is right join? That means if we take, sorry, if we take the same example, we have 1, 2, 3, 4, 5. Here we have 1, 2, 3, 6, and 7. In the output, once we apply right join between these two tables, the output will be common elements, that is 1, 2, 3, along with all the elements that is present in the right side table, that is second table. Okay. Now, the last one is full join. Okay. Like I said before, full join. I mean, MySQL doesn't support full join directly, but we can get the same output as full join by using union, left join, and right join. Right? Now, full join retrieves all the rows from both the tables. Okay. This retrieves all the rows from both the tables, and this retrieves null values when, I mean, null values if value match is not found. That means, for example, for any value, there is no match in the other table, then this returns only null values in place of that. Okay. Value match is not found. All right. Same example, if I have to say 1, 2, 3, 4, 5. Here we have 1, 2, 3, 6, and 7. If you just apply full join between these tables, in the output, we'll get all the elements from both the tables. Okay, that is 1, 2, 3, they are common elements. 4 and 5 from the left table, 6 and 7 from the right table. Okay, clear with this? Now, let us go back to MySQL Workbench and see some examples around this. Okay, so MySQL Workbench, I'll just add a new query sheet. Now, let us start by creating a database. Create database. I'll just name this database as Sandeep, for example. Okay, I'll just execute this. Successful. After that, use Sandeep. Execute this. Successful. Now we'll just create a couple of tables. Okay, for that I have the code ready with me. I'll just copy this, paste it here. Here, what are we exactly doing? We are just creating two tables. One is departments table and inserting values into departments table. After that, employees table. Then we are just inserting values into the employees table. Now, for example, I'll just show you the content also. Select star from departments. Just execute this. You'll get to see the department table. There are four values, I mean, four records and two columns, department ID and department name. Now, select star from employees, for example. Okay. If we just see, we have five records: employee ID, employment name, department ID, and also salary. If you have observed closely, department ID is a common column that is present in both the tables, right? Now, first we'll see about inner join. Okay, like I said earlier, this only retrieves all the common elements. Okay, for example, if we just write the query as select employees dot employee underscore ID. So this is how we write. First, we write the table name dot, after that the column name that we want, right? Employee ID, comma, employees, sorry, employees dot employee name, comma. Now from the second table, that is departments table, department name. Okay. Now from employees table, I'll just write it as inner join to departments table. Okay. Now here we'll use one small function, that is on function. Okay. Clear till here? We are just doing, I mean, we are just writing it as select from the employees table, employee ID, from employees table, employment name. After that, from departments table, department name. Now from here, from employees table, we are just inner joining onto departments table. Now here we are using just a small function, that is on function. After this, we'll just have to give the common column. Okay, the common column between the two tables is nothing but department ID, right? Employees dot department ID is equal to departments dot department ID. Okay, if we just execute this query, you'll get to see only those records which are common in both the tables. Okay, so these four are the only common records present in both the tables. Now this is how we apply inner join. Now for example, okay, here I'll just write the question also. Retrieves only employees that are associate associated with a department. Okay, so this query that we have written retrieves only employees that are associated with a department, right? So that is how we use left join, sorry, inner join. Now left join, what exactly this does? All the common elements plus all the other elements from the left table. Okay, now for example, we want to return all the employees including those who don't belong to any department. Okay, returns all, I mean, we want to return all the employees including those who don't belong to any department. Okay, now for these kind of employees, for for these employees, department information will be null. Okay, now how do we write the query? Select employees dot employee ID, comma, employees dot employee name, comma, departments dot department ID. Okay, after that, from employees, now I'll use left join. Okay, same query as inner join, but in place of inner join, we are just using left join. Okay, next. Okay, sorry, we'll change this as department name. Okay, so left join onto departments on. Now we have to just give the common elements, common column. Employees dot department ID is equal to departments dot department ID. If we just execute this, error, department spelling. Okay, now if we just select this, execute, you'll get to see all the employee names along with the department name, and wherever there is no department present, we'll get the null value. Okay, clear with this? Now this is how we write left join. Next we have right join. Okay, now for example, now what exactly does right join do? Returns, I'll just copy paste this, returns all the common elements plus all the other elements from the right table. Okay, now here we want to return all departments, for example, departments, even if no employee is assigned. Okay, we want to return all the departments even if no employee is assigned. Okay, now here employee information will be null for such departments. Okay, wherever the department is present and employee details are not found, there it will return null values. Now how do we write the query? Select employee Okay, just give me a second. All right. So select employees dot employee ID, comma, employees dot employee name, comma, departments dot department underscore name. After that, same from employees table. Now we'll use right join onto departments table on what is the common column? Employees dot employee ID is equal to departments dot department ID. Okay, so this is how we write the query. If we just execute this, you'll get to see all the department names, but we are just, I mean, we want to show all the employment information also. But for all these, I mean, department names, there is no employment information. That's why it is showing null. Okay, understood? We are just returning all departments, even if no employee is assigned to each of those departments. There we'll get null values, obviously, right? So that is about right join. Next we have full join. What exactly this full join does? Nothing but returns all the rows from both the tables. Okay, we'll see how is that done. Okay, like I said earlier, MySQL doesn't support full join, and we can get the same output using union, left join, and right join, right? So I'll just copy this code that we have done for left join. Same thing. I'll just show you. Copy, paste. After this, I'll use union operator. After this, we will just select this right join. Okay. If we just select this, copy, paste it here. Now the combination of union keyword, I mean union function, left join and right join. Now here what will be the result? We'll see. This returns all the rows from both the tables. If we just select this, execute, you'll get to see all the details from both the tables, and wherever the information is not available, there will get null values. Okay, so this is how we use the combination of union, left join and right join to return all the rows, all the records from both the tables. Okay, understood? Now, next is, for example, I mean the last one, like I said, cross join. Okay, now if I just write the query like this, select employees dot employee name, comma, departments dot department name from employees cross join onto departments. Okay, now we'll see what exactly does this return. Unknown employee spelling. Okay, if we just execute this, this will return all the I mean the combinations. Okay, this will return the combinations from both the tables. Okay, so this returns um, all the combinations of the records. Okay, like, okay, if I have to show you the example, I'll just show here. All right. For example, in one table, we have um, A, B, C. In another table, we have D, E, F, whatever these values might be, employee names or department names, whatever it might be. So using cross join, we'll get combination of all these things. That is A, D, A, E, A, F. After that, BD, BE, BF. After that, CD, CE, CF. So whenever we want these kind of combinations, right, from both the tables of all the records, we use cross join. Okay, this is used very, very rarely, right? Same thing with self join also, right? We don't have to look into that now. Once we understood cross join, next I have some questions. We'll discuss some questions on this. Okay. First, let us see the tables exactly. Okay. Select star from employees. So there are 5 records. After that, select star from departments. Okay. If you just execute this, there are 4 records. Now, for example, I want to list all the employees with their department names. Okay. Like this, we'll see some questions. I want to list all the employees with their department names. Okay. How do we use joins here? We will use inner join for this, right? Because using inner join, we get the common elements from both the tables, right? That is what we want to return. All the employees with their department names. Okay. Now the statement will be select employees dot employee ID or employee name. Okay. And departments dot department name. Okay. From employees inner join departments table on. Now we have to give just the common column, that is department ID is equal to departments dot department ID. Okay. If we just execute this, we will get all the employee names along with the department names. That means we have the department details for only these employees. Okay. So that is the meaning of this question. All the employees with their department names. All right. So next, uh, list all the employees even if they don't belong to any department. Okay. We have already seen this example. This is possible using left join. I'll just copy this same statement, paste it here, and in place of inner join, we'll use left join. If we just execute this, you'll get to see all the employees, even if they don't belong to any department. That is, department information is not present. That is null, correct? Now, next example, we want to list all the departments now, okay, and their employees, okay, include departments with no employees. Okay, this is what we want to get now. Now we'll write the query as select departments dot department name, okay, comma employees dot employee underscore name from departments table. Okay, we'll use left join here again, left join employees. Here we are just doing the left join between departments table and employees table. Left join employees on employees dot department ID. Okay, this is mandatory, guys. Understand this. We have to definitely mention what is the common column. Employees dot department ID. Next, departments dot department ID. Okay, if we just select this, execute, we'll get all the department names and employee names which are associated to those departments. And this returns null value if there is no employee information for a particular department. Okay. Understood this? Next, we want to show uh, employee names along with departments, okay, or along with department names, even if uh, either is null. Okay, whatever. I mean, we just want to show names, employee names, along with the department names, even if either is null. That means employee can be a null or department can be a null. Okay, for this, that means basically we are just returning all the records from both the tables. Okay, this is the meaning of this question. Now, I'll just write it as employee ID, comma, departments dot department name. Okay, here also we'll use name, employee name. Next, we have from employees left join. Why am I using left join? Because full join is not supported. Left join departments table on employees dot employee ID is equal to, sorry, on employees dot department ID is equal to departments uh, dot department ID. Okay, till here it is left join. I'll use union. After that, I'll just write this as select. Again, same thing, but in place of left join, we'll just use right join now. Copy, paste it here, and in place of left join, we'll use right join. Query is completed. Now, if we just execute all of this, we will get all the records from both the tables. Where, I mean, from the employee table, employee names, all the employee names, and from department table, department name. And this returns null value if either is null. I mean, either of the information is not available. Okay. Now, next question. We just want to show um, departments with no employees. Okay. Just want to show departments with no employees. And we'll just write the query as select departments dot department name. Okay. From departments table left join employees table on employees dot department ID, okay, is equal to departments dot department ID, where employees, here we'll use where clause, employees dot employee ID is null. Okay, this is how we write this. This shows all the departments with no employees. That means employee records should be null. If you just select this and execute, you'll get all the department names where the employee details are null. Okay, like that we have only one department, that is marketing department. Understood this? Next, we want to find employees working in the IT department. Okay, for example, this is our requirement. Now, here what exactly do we use? Select employees dot employee underscore name from employees table, and I'll just write this as join. Okay, departments on, okay, we are just joining employees table with departments table on employees dot department ID is equal to departments dot department ID. Okay, now where, again where clause, where departments dot department name is equal to IT. Okay, this is how we write, because we are specifying the condition here. We just want only those details which belongs to IT department. Okay, if we just execute this, you'll get to see all the employee names um, who works for IT department. Okay, now next, for example, we want to get employee and department details in ascending order, for example, ascending order of salary column. Okay, how do we write the query for this? We'll just write it as select. First thing, what exactly, which join we'll use here to get all the employees and department tables, I mean department details in ascending order from salary column. We'll use left join here. Okay, select employees dot employee ID, sorry, employee name, comma, departments dot department name, comma, employee salary also, right? Employees dot salary. Okay, these are the columns that we want from employees table, left join departments on employees dot department ID is equal to department, sorry, departments dot department ID, and the condition is sort them in ascending order, right? For any kind of sorting, we'll use order by function. Order by employees dot salary in ascending order. Okay, if we just select this query, execute, we'll get to see all the employee names and also department names which are sorted in the ascending order. Okay, that is what we want, right? Get employee and department details in ascending order for the salary column. Okay, understood this? Next. Okay, next example is if we just want to count, for example, count number of employees for, I mean, employees per department. Okay, we just want to count number of employees per department. Again, we'll use left join here and write the query like this. Select departments dot department name. Okay, and I'll just write it as count. This is the aggregate function that we use. Employees dot employee ID. We are just counting employee IDs and showing the new column as employee underscore count. Okay, from departments table, left join employees table on common column. Employees, sorry, departments dot department ID is equal to employees dot department ID. Okay, clear till here? Next, we'll have to use group by function. Group by departments dot department name. Okay, if we use group by on department name column, then we'll get the count of employees for each department. Okay, now if we just execute this, you'll get to see how many employees are present for each department. Here we are, I mean, we are just counting employee IDs and mapping that with department name using left join. Okay, here what is the logic here? On the, I mean, if we use left join, we'll get all the details from left table. That is all the department names, because departments here is the left table, right? Here you can confirm that employees on, we are joining this department ID onto employees table department ID. So this departments will be the left table, and we'll get all the uh, records in this department ID from the departments table, and similarly we'll get number of employees, count of employees from the employee table. Okay, this is how we write the query. Next, if you just want to find mm, departments with more than one employee, for example. Okay. Find departments with more than one employee. Okay. Here, if you see this output in this, in the query that we are going to write, the output we need to get is only IT department, right? So in IT department only, there are two employees, right? Now we'll just write the query as select departments dot department name, comma, here also we'll use count function, employees dot employee ID, employees, okay, count employees dot employee ID and show that as total employees, for example, from departments table left join employees on, I'll just copy paste this, okay, on departments dot department ID is equal to employees dot department ID. Now, for that we have to use group by departments dot department name. Once we group this, then we have to use having clause, having count of employees dot employee ID greater than 1. Okay, so this returns all the departments with more than one employee. Here the logic is we are using left join, and left table is departments table, right table is employees table, right? Now we are just grouping that by department name and using having function to filter the data where the employee count, right? Employee ID count is greater than 1. If we just select this, execute, like I said earlier, we'll get only IT department because only in the IT department, the count of employees is more than 1, right? So this is how we write. We'll see a couple of more examples also. Now, for example, mm, find the employees who earn more than, uh, for example, department's average salary. Understand this question? We want to find all the employees who earn more than department's average salary. Okay. Now, how do we write the query? Select employees dot employee name, comma, employees dot salary. Okay. Comma, departments dot department name from employees. Okay. Join. I'll use just join here. Departments. Okay. Departments. Next, departments. Um, Here we can use join, or simply we can also write it as inner join because both are same, right? Wherever we use join simply, that means we are using inner join. Okay. Inner join departments on employees dot department ID equal to departments dot department ID. Okay. Now the logic is we'll use where function here where employees dot salary, okay, is greater than, right? I'll use a subquery, that means select statement inside another select statement where employees dot salary is greater than. Now we have to find average of salary, right? Select uh, average of, we can just write it like this. Okay, average of employee dot salary, okay, from employees. Next, where employees dot department ID is equal to departments dot department ID. Okay, till here we are just calculating average of salary, right? Now, if we just close this and execute this, you'll get to see employee names who earns more than department's average. Okay, how do we calculate department's average? Like this. Okay, this is the query to calculate department's average. Select average from employees dot salary, that means salary column, from employee table where we need to mention the common column. Okay, now this is how we write this query to find employees who earns more than the department average salary. Okay, so next, for example, we want to get all the employee details with null department. Okay, how do we write the query for this? Simple thing, select employee name, comma, salary from employees table where department ID is null. Okay, this is how we write. If we just execute this, okay, unknown column salary spelling is wrong. Select this, execute. You'll get to see employee details with null department. There is no department details for this employee. Okay, now next, for example, we want to get all department, okay, department names that do not have any employee earnings more than 70,000. Okay, so this is a question. Read this carefully. We want to get all the department names that do not have any employee earning more than 70,000. Okay, now the query will write this as select departments dot department name from departments, okay, left join onto employees table on departments dot department ID is equal to employees dot department ID. Okay, clear till here? Now we'll use group by function here. Group by departments dot department ID. After group by, departments dot, okay, let it be department ID. And also we'll group by departments dot department name. Okay, having maximum of employees salary less than or equal to 70,000. Okay, or max of employees dot salary is null. Okay, if we just execute this, you'll get to see all the department names that do not have any employee earning more than 70,000. Okay, clear? That means basically in these department names, all the employees earn less than 70,000 or the salary is null. Okay, so that is the exact meaning of this. Now, that is how we write the query. Next question, for example, we want to display departments and the highest salary in each department. Okay. For this, how do we write the query? We will just um, write this as select departments dot department name, comma, maximum of employees dot salary, and show the newly created column as highest salary, highest underscore salary. There shouldn't be any spaces between the names. From departments table, left join employees on departments dot department ID is equal to employees dot department ID. Clear till here? Now we'll group by, okay, group by departments dot department ID, okay, space, group by departments dot department ID, comma, departments dot department name. Okay. Now the output will display all the departments and the highest salary in each of those departments. If we just execute this, departments spelling. Okay, where is that? Departments here. Okay. If we just execute this, you'll get to see all the departments along with their highest salaries. Okay. For example, in IT department, the highest salary is 80,000. That means, for example, IT department consists of 10 employees, right? Among those 10 employees, 80,000 is the highest salary. Okay. Understood? We are just joining both the tables and we are just grouping them by department ID and department name. Okay. For each department, we calculate the maximum salary among its employees. Okay. That is how we write the query for this. Next, for example, we want to show employees along with department names sorted by department. Okay, sorted by department. That means in the alphabetical order. Okay, here if you see the previous output, H, I, S, M. These are the first letters of the department names, right? Now we are just trying to order them in ascending order or descending order. That is from A to Z or Z to A, basically. Okay. Now the query will be select employees dot employee name departments dot department name. After that, from employees table, left join departments on, okay, employees dot department ID is equal to departments dot department ID. And after this, we just have to write order by function, order by departments dot department name. Okay, this is the query to show all the employees along with the department names sorted by department name in the A to Z format, for example. Okay, if we just execute this, you'll be able to see the output. Okay, clear with this? That means in the department name column, all the values are sorted from A to Z. Okay, right. So that is how we show employees along with the department names sorted by department. Next, and this will be the last question. For example, we want to find employees who do not have any department assigned. Okay, that means department name should be null. I mean, department ID should be null. How do we write the query? For this, I mean, we did not to use joins also. Select employee name from employees where department ID is null. Okay, this query shows employees who do not have any department assigned to them. I'll just execute this. There is only one employee. I think we have seen this already, right? So this is how we calculate. I mean, we find employees who do not have any department assigned. Okay, so this is about joins. All right, we have seen around 15 to 20 examples for these joins, right? In simple words, if you have to say, joins are used to combine the data from both the tables, right? And in types of joins, we have inner join, left join, right join, and full join. There are other two joins also, that is cross join and self join. We, in 100% of the cases, I mean 99.9999% of the cases, we don't use cross join or left join. They are most rarely used, right? So this is about the joins. Next, we'll see constraints. So we'll see window functions now. Window functions. These are used, I mean, window functions performs a calculation, okay, across a set of rows that are related to the current row. Okay, this performs a set of calculations across a set of rows that are related to the current row. Okay, without collapsing the result. Okay, so this is the basic definition of window functions. In simpler words, if you have to define this window function, this is a function, okay, which uses the values from single or multiple rows, okay, to return a value for each row. Okay, in simpler words, these are the functions which uses values from single or multiple rows to return a value for each row. Okay, this is the basic definition of a window function, right? Now, next is syntax. Okay, now what is the syntax? We will start with window function. After that, expression, right? Expression. After that, we will write it as over partition by. We'll see what exactly is this partition by. Partition by column name. Okay, we can use a number of columns here. Partition by column name. After that, we will use order by function, column in ascending or descending order, right? After order by, we'll use rows between function. Okay, then this is the end of window function syntax. Now, what exactly is this partition by? Partition by, partition by. This basically divides result, okay, set into partitions. Same like group by, okay, same like group by, but this doesn't reduce the rows. Okay, for example, we have a region column, for example, okay, in region north, south, east, and west. Okay. If we want to partition this region column, we can partition it by first and second. This is the first partition and this is the second partition. In first partition, we have north and south. In the second partition, I mean in the second set, partition is also called as set, right? In the second set, we have east and west. Okay, clear with this partition by? This is just nothing but dividing the values into some partitions or into some sets, right? Next, as we already know, what is order by? This nothing but defines the order of rows within each partition. Okay, once the column is partitioned, that will be considered as different sets, different partitions, right? For each of those partitions, we can do order by, right? Next is rows between. This is optional frame clause. I mean, we can use this or we don't have to use this also. This is used to define range of values or range of rows. Okay, understood what is um, rows between? Now, what are all the window functions do we have? First, row number, right? After that, rank. Next, next, dense rank. Dense rank is also a window function. After that, we have lag. Fifth one is lead. Then we have first value, right? After this, we have last value. After this, this can also be nth value. Okay, we'll see all of this with example. So let's go to my SQL workbench. All right. Here is my SQL workbench. I have added a new query editor, right? So we'll start with creating a database and creating a table. So create database. I'll just name this as window functions. Okay, let's execute this. Use window functions. fun. Okay. Now inside this, let us create a table also. For that, I have the code already. I'll just copy this, paste it here, and let's execute this. Here we are we are creating a sales data table. After that, inserting some values into it. If we just have to show the values, select star from sales data. We just execute this. You'll be able to see the table. All the values that we have inserted. So first we'll talk about row number function. What exactly is this row number? This assigns a unique sequential value to rows within a partition or without a partition also, right? We'll see how that is done. For example, and this sequential numbers starts from 1, right? Sequential numbers starts from 1. Okay. Example query. We just write the query like this. Select employee name, comma, department, comma, sale amount. Okay. Next, comma. Here I'll use row number. Okay. Row underscore number. This is the function that we have to use. Row underscore number. Next, over partition by department and order by sale amount in descending order, for example. Close this and show the newly created column as row number, for example, from sales underscore data. Okay, I'll select this and execute. You'll be seeing the row numbers for each of them, right? It is showing 1, 2, 3, and again starting from 1, 2, 3, 4. Why? Because we are partitioning the department column. Electronics is one partition, furniture is another partition, and in electronics we have three rows, right? So that's why each of that row is ranked with a sequential number 1, 2, and 3. And in furniture we have four values, right? Each of those values are ranked from 1, 2, and 3, and 4, right? Now if we just remove this partition by department, okay, and execute everything again, now you'll see for each and every row the rank, I mean the sequential row number is assigned without any partitions, right? Understood this, how to use row number? Next we'll talk about rank function. Okay, rank, this is very similar to row number. Okay, very similar to row number, but this gives the same rank when values are equal. Okay, this gives the same rank if the values are equal. For example, okay, I'll just copy this, paste it here, and change this row number and write as rank. Okay, I'm just changing this row number and replacing that word with rank, and show the new column as ranking, for example. Okay, if we just select this, execute, if you observe, right, for 1200, there are two values of 1200, right? For those two values, this is assigning the same rank, okay, 2 and 2, right? Understood? And skipping third rank, okay? Now, similarly, if we write partition by department, okay? Now, if we execute this, you'll see the ranks. Now there is no similar rank. That is for each of those 1200, the rank is different because they are in different partitions, right? Understood how to assign rank for each of the value? So that is about the rank function. Next, we have dense rank. Okay, what exactly is this dense rank? Like rank function, same like rank function, but this doesn't um, leave any gaps, okay, between the ranks. For example, now you will understand the difference between this rank and dense rank. If you just write the query, I'll just copy this, paste it here. I'll replace this rank with dense underscore rank. This is the function that we have to write. I'll also remove this partition by department and name the new column as dense ranking. Okay, if you just execute this, you'll be seeing previously when we used rank function, 3 was skipped, right? Third rank was skipped. Now this also assigns for 1200. I mean, there are two values of 1200, right? So for each of them, it assigns same rank, but previously third rank was skipped. Now using dense rank, there will no skipping of ranks. Okay, each and every rank will be assigned. Understood the difference between rank and dense rank? Yes. Next, we have lag and lead. First, we'll see what exactly is lag function. This fetches the value from the previous row. Okay. Now, how do we write this? Same thing. I'll just copy, paste it here. Now, in place of dense rank, we will write it as lag of sale amount, for example, lag of sale amount over partition by departments. We can use partition here also, or else we can just leave it. Order by sale date now. Sale date, descending order. Okay. As I'll just write this as previous value from sales data. If we just select this, execute, you'll see that newly created column for each of the value. I mean, for each of the row, this is assigning the previous row value. That means, for example, for 700, if you see the newly assigned value is 1000. And what exactly is 1000? 1000 is the previous value of 700, right? So that is how this assigns. Now for the first value, it is showing null because there is no previous value for 1200. Understood this? What exactly is lag? Lag just fetches the value from the previous row. Okay. Similar to lag, we have lead. This fetches the value from the next row. Okay. Now I'll use the same statement again. Copy, paste it here. In place of lag, I'll just use lead. Lead sales amount, and I'll name this column as next. Okay. If I just select this, execute, you'll see for each of the value, the next row value is assigned. For example, for 700, previously when we used lag function, this assigned 1000, right? Because 1000 is the previous row value of 700. Now, this lead function assigns the next row value, that is 1500. That's why 1500 is assigned to 700. Okay, understood this? So this is about lag and lead. Next we have first value and last value. Okay, first we will talk about first value. This returns the first value in an ordered partition. Okay, this simply returns the first value and assigns to each and every value. And if we just copy this again, paste it here. Now in place of lead, I will just mention first underscore value. Okay, first underscore value of sale amount over partition by department. We can use that, or we don't have to use that. If I just select, okay, I'll just change the name of the column. Data next value. In place of next value, I'll write as first value. Okay. We'll write it like this. No, first value. Okay, if we just execute this, you'll get to see for all of these values, 1200 is assigned. Why? Because 1200 is the first value in the sales amount column. Okay, now here, rather than 1200, if we have 950 as the first value, all the other rows in the newly created column will be assigned with 950. Okay, clear with this? Understood? Yes. Next, so this is about the first value. Similarly, we have last value. Now, what exactly is the last value? This assigns the last value in the uh, range of cells. Okay, for example, in the sales amount, last value will be assigned. And we'll write the query as like this: select employee underscore name, department, comma sale, amount, comma last underscore value of sale amount. That means we are fetching last value from the sale amount column. I'll write it as over partition by department. Okay, and order by sale date. Okay, next I'll write it as rows between, okay, rows between space. I'll have to use this syntax, small syntax. I will write it in the next line. Inbounded precedings, okay, and unbounded. Sorry, this is not inbounded. This is unbounded. Unbounded precedings and unbounded following. Okay, so this is how we need to write the syntax. Unbounded preceding and unbounded following. Okay, preceding spelling, there should be only one E. Okay, now after this, show the newly created column as last value. Okay, last value from sales data. If we just execute this, you'll see that last value in the sales amount column is assigned to the each and every value in the newly created column. If you just execute this, error, okay, sale amount spelling, okay. Where is it? Here, sale amount. Now, if you just select this, execute again, sale date. Now you will see that 1200 is again the last value. Now here it shows 1000 and 1200 because we have just partitioned by department. If we just remove this partition by department, okay. Now if we just execute this, you'll see that 1200 is assigned again because 1200 is the last value. Okay. For example, here the last value is 700, for example. 700 will be applied to each and every value in the newly created column, right? So that is how we assign last value to each and every row in the newly created column. Similarly, we can also assign nth value, right? And how is that done? Same query. I'll just copy this, paste it here. In place of last, I'll just mention nth value. Okay. Here also n value, right? In the nth value, again, I have to mention which nth value. For example, second value. That means 800 will be assigned to each and every row. Okay, understood? We'll just execute this. You'll see that 800 because we are giving 2 here. That means second value. We are fetching second value from the list amount, sales amount column and assigning that value to each and every row, right? I can just name it as second value. Okay, this can also be done. So that is about first value, last value, and nth value. And that is about window functions. So constraints, okay? Constraints. We'll see what exactly are constraints. First in theory way, and then we'll go to MySQL Workbench and see syntaxes of these constraints, okay? These constraints are otherwise called as integrity constraints, okay? Integrity constraints. Now, what exactly are these integrity constraints? These are the rules, okay? These are the rules that ensures the accuracy of the data and consistency of the data, okay? They prevent any invalid data to be inserted into a table, okay? They are constraints are nothing but they are basically some rules which ensures that there cannot be any invalid data to be inserted into a table. Okay. Now, if you know this concept in Excel, that is data validation. Okay. I hope you know this topic in Excel, data validation. Data validation in Excel and integrity constraints, these are like same, not exactly same, but almost similar. Data validation also restricts the invalid data to enter into a table. Okay, these are also some set of rules which restricts the data. Okay, now there are six integrity constraints. One is primary key, foreign key. Okay, next is unique constraint. Next, we have not null constraint. Next, we have check constraint. So all of these are nothing but constraints. And the last one we have default constraint. Okay, we'll see what are all these one by one. Primary key, or let's go to MySQL workbench and see them with syntaxes. Okay, now I'll just add a new SQL script. All right. So first we'll talk about primary key constraint. What exactly is primary key? Everyone knows that primary key ensures that each column, I mean each record in a column is uniquely identified. We cannot have any duplicates in the primary key, right? We know this already. Okay. Same, uh, I mean that is nothing but a constraint. Okay. We are restricting any duplicate values to be inserted into a table. Okay. Understood? Now, okay, let me write the definition also here. This ensures the column that, this ensures that the column only have unique elements or records. Okay. Now, syntax, we can write it as like this. While creating the table itself, we'll create the columns, then we'll specify whether it is an integer data type, varchar data type, right? At the same time, while create, we'll start with creating table, create table. For example, we are creating employee table. We have employee ID column. Okay. After that, we have employee name column, for example. Now, employee ID, int, and as well as primary key. Okay. That means in employee ID, each and every record should be uniquely identified. We cannot have any duplicate values. Okay. Right. So this employee name, obviously, varchar of 10, for example. Okay. Now this is how we declare that a particular column is a primary key. Okay. Next, foreign key. What exactly is foreign key? This is to maintain relationships between the table by linking a column in one table to primary key in the other table. Okay. So the definition is maintains the relation between the tables, okay, by linking a column in a table to the primary key in another table. This is the definition of primary foreign key. Now, how to declare whether a particular column is a foreign key or not? For that, we will have to create two tables basically. Okay, this is how we declare foreign key. For example, we are creating a table that is department table. Okay, in this, I'll just mention department ID int primary key. Next, we have department name as varchar of 50, for example. This is one table. Second table, I'll just create another table that is employee again, for example. Okay, here employee ID int primary key. For this particular employee table, the primary key will be employee ID. For the departments table, this is department ID, correct? Now name varchar of 50. Next, department ID, which is int. Okay. This department ID and this department ID are same. We need to have a common column, correct? Now department ID in a department table and department ID is employee, a department ID in the employee table, these both are same. Okay. Here I'll just mention it as int. Now to declare this department ID as a foreign key, we need to write it like this. Foreign key of department ID. Okay, once we mention department ID inside this foreign key function, that becomes a foreign key. Next, we need to reference it. References to which column in another table? References department table and department ID column. Understood how to declare this foreign key, right? First, we have created a department table where the primary key column is department ID. Now, to link this primary key in departments column to another table, that is employees in this example, employee in this example, department ID, we need to mention that department ID in employee table is the primary key and which references department ID in the department table. This is how we create or we say that a particular column in a table is a foreign key. Okay. Next we have unique constraint. This ensures that all the values in a column are distinct. Okay. But this also allows the null values. In primary key column, we cannot have null values. Here, unique constraint ensures that all the values in the columns are distinct, but this also allows null values. Now, how to declare this? I'll just write it as while creating the table itself, employee, for example, employee ID int primary key. Now I'll use email. Okay, this is another column name as varchar of 50. Here I'll just write it as unique. That means email column in this employee table is now with unique constraints. That means we can enter only unique values in this email column that can be null also. Okay. This is how we deal with unique constraints. Next we have not null constraint. Now, what exactly is this not null constraint? This ensures that a column cannot have a null value. Okay, this ensures that a column cannot have a null value. Now, how to write this? How to declare this? Create table employee ID int primary key, comma. Now we'll take name varchar of 50 and I'll mention for this column as not null. Okay, that means in this name column, we cannot have any null values. Each and every value should be valid. We cannot have any null values here. So that is the meaning of not null. Now next constraint is check constraint. What exactly is this check constraint? This restricts the values based on a condition. For example, we have age column in our table. Okay. Create table employee. In this employee ID int primary key. Next is, for example, we have age column. Okay, age is int. After that, like a continuation, we'll just write it as check if age is greater than 18. Okay, inside check, we are just mentioning if age is greater than 18 or not, or we'll just directly mention greater than or equal to. That means in age column, this check constraint will only allow numbers, integers that are greater than 18. Okay, this check constraints check each and every value if that value is greater than or equal to 18. If the value is greater than 18 or equal to 18, then only it allows that value to enter into the column. Okay, that is how we declare or we use check constraints. Next, we have default constraint. What exactly is this default constraint? This assigns a default value if value is not provided. Okay. Now how to use this? I'll just write it as create table employees employee ID int primary key. Next, name, for example, varchar of 100. This will take as not null. After that, department name. Okay, varchar of 50. For here, for this department name, I'll just mention this as default, and space, I'll just mention it as general. That means wherever we don't give any value for this department name column, there the value will be automatically written as general. Okay, that means if no department name is provided, this will give general as a value, general department. Okay, that is about default constraint. So this is the end of constraints or integrity constraint, and also all the topics in SQL. Next, we'll see interview questions. When it comes to interview questions, we have a sample of 20 questions here. Okay, so we'll try to answer each one of them in MySQL workbench. All right. So before doing that, let us go back to MySQL workbench and start with creating a database. Create database. I'll just name this database as S, for example. Okay. Now use S. After that, we'll create three tables now. Okay. I have the code written already. I'll just paste it here. So based on these three tables only, most of the interview questions will be answered now. Okay. I'll just execute this. We have departments table, and next we are inserting some values into departments table. Next is employees table. Insert some values into employees table. After that, sales table, insert some values. Okay, so we have created three tables. If we just have to see the content, I'll just write it as select star from employees first. If you execute this, you will be able to see there are 10 records in this employee tables. Okay, 10 records and 6 columns, right? Similarly, if I just write this statement as select star from departments, you'll be able to see there are 2 columns with 5 records each. Next, select star from sales. Here we have again 10 records with 4 columns. Now, let's go back to the questions. Okay, first question. What is SQL and why is it used? Right? Everyone knows that SQL stands for Structured Query Language. Why structured query language? Because in data analytics, we only deal with structured data, the data which can be stored in the tabular format, right? That's why this name has been derived, that is structured query language. Now, why do we use exactly SQL? Because we need to interact with the data, correct? Interact with the data. When I say interact, we can do CRUD operations, CRUD. That stands for create, retrieve, okay, update, and delete. So these are some of the operations that we can perform on data. Okay, right. So next question, what is the difference between having and where clause? I hope we have already seen where clause, right? Similar to where, we have having clause also. Both are nothing but used to filter the data, right? But the main difference is where is used to filter the rows before any groupings. Okay, before any groupings in simpler words. Or this is used to filter the rows before any aggregates. Okay, now next is having. Okay, is used to filter the rows after the grouping of data. Okay, now if I just have to show you the example for where clause first, right? Where clause, for example, we want to find employees with salary greater than 60,000. Okay, we'll use where clause there, and we write the query as select star from employees table, okay, where salary is greater than 60,000, right? If we just execute this, you will be getting all the employee details whose salary is greater than 60,000. Okay, next example for having. If you have to find department having more than 2 employees, for example, okay, finding, here I'll write the question also, finding departments having more than 2 employees. Okay, how do we write the query? Select department ID, okay, comma, count of star. That means we are trying to get, we are trying to count all the rows from this table, okay, and show the newly created column as employee count, for example, okay, from employees, that is the table name, group by department ID having count of star which is greater than 2. Okay, understood this? From employees group by department ID. Okay, this is fine. If you just execute, you'll get department ID 2, and in second department ID we have employee count 3. Okay, in all the other departments the employee count is less than 2, or it might be equal to 2. Okay, so that is how we use having clause, right? Second question answered. Third one, what is the difference between delete, truncate, and drop? Okay, we already know this. Just for your knowledge, I'll just repeat once again. Delete, truncate, drop. First, we'll see what exactly is drop. Okay, drop deletes the data in the table. Okay, now next, and this is a permanent change. Next, truncate. This also deletes the data, okay, but the structure of the table remains. Next, and now this is also a permanent change. That means once the data is deleted, we cannot get it back, right? Next is delete. This also deletes the data, but temporarily. Okay. That means if we want to get the data back, we can roll back it. That means in simple words, we can get the data back, right? So that is the difference between drop, truncate, and delete. For if we have to give some examples, we can just simply write it as delete, sorry, delete from employees where salary is less than 50,000, for example. Okay. If you just execute this statement, you'll not be able to see in the employee tables all the salaries below 50,000. All those will be deleted. Okay. So this is the syntax. I'm not executing that. Next, for truncate, we can just directly write it as truncate table and table name, right? For drop, drop table and table name. Using drop, we can uh, drop the table, drop the whole database also. Okay, so that is the difference between drop, truncate, and delete. Next question. What is a primary key? Can a table have more than one primary key? All right. Primary key. We already know this, that a primary key is a column or the combination of columns that uniquely identifies each row in a table. That means each and every entry, each and every record, each and every row in a table should be uniquely identified. This primary key cannot have duplicates as well as null values. Primary key column cannot have duplicates and also it cannot have null values. Okay, this is the first part of the question. Second part of the question is, can a table have more than one primary key? The answer is direct no. Okay, table cannot have more than one primary key. Okay, right. So again, how do we declare if a column is a primary key or not? While creating the table, create table, table name, whatever it might be, tab, for example, okay, and employee ID is int, and here itself, we'll just mention it as primary key. That means in the employee ID column, we cannot have null values. We cannot have duplicate values, right? That is the fourth question. And next, what are the different types of joins in SQL? Explain with examples. Okay. Joins, what exactly are joins? They are used to combine the data coming from two or more tables. Okay, they are used to combine the data from two or more tables. Now, what are the types of joins that we have? Inner join, okay, left join, right join, and full join. Okay, so these are the four main types of joins. We also have two more joins. They are self join and cross join. Okay, examples, we have already seen the joins topic here, I guess. Okay, so here, if you just go through this query, select employees dot employee ID. That means from the employees table, we are trying to get employee ID. Similarly, from the same table, employee name. After that, from sales table, we want to get amount column from employees. Inner join sales on. Okay, this is how we use inner join. We are joining employees on sales. Okay, on. After this on, we need to just mention which column are we using to join these two tables. That means nothing but common column that is present in both the tables. From employees table, employee ID. From sales table also, it should be employee ID. Okay, this is how we use inner join. Similarly, left join, nothing but in place of inner, we'll just substitute left. Okay, similarly right and also full join. By default in MySQL full join doesn't support, so that's why we use left join, union, right join. Now what exactly are the functionalities of these joins? Okay, what will be the output for these joins, right? For inner join, if we just combine any two tables using inner join, that retrieves all the common elements from both the tables. Okay, all the common elements from both the tables. What is left join? This retrieves all the common elements along with all the other elements that is present in the left table. That is first table. Okay, clear with this? Next, what exactly is right join? Right join retrieves all the records which are common and also retrieves all the elements that are present in the right table. Right? Understood this. Next, full join. Full join retrieves all the elements from both the tables, whether it might be common, it might be duplicate, whatever it is. Okay, this returns all the elements from both the tables, and this returns null values if value of record doesn't match. Okay, clear with these joins? All right. So this question done. Next, what is the use of group by clause in SQL? Why do we exactly use group by? Let's go here. Okay, so that is about joins. Now, group by. Okay, why do we exactly use group by? This is used to group the rows with the same values into summary rows. Okay, that means, for example, we'll see an example. For example, if we just write the query like this, select department ID, comma, count of star, okay, as number of employees from employees table, group by department ID. That means for each department ID, we are trying to extract the number of employees. If we just execute this, you will be able to see for first department ID, there are 2 employees. For the second department ID, there are 3. Similarly, for 3, 2 employees. For 4 department ID, 1, and 5 also 1. And one null value, okay? I mean, where their department ID is null, and like that we have 1 employee, right? So this example, question of this example is to get number of employees in each department ID. Okay, right. Group by, done. Next, what is the difference between null and zero in SQL? Null and a zero. So most people will be confused here. First, null is nothing but a missing value. Okay, that means there is no value in that. Next, zero, zero, it's a known value, right? It is a known value. That means, for example, if we take salary column itself, there might be some employees whose salary is zero. Also, that is a possible situation, correct? Right. So that is how, that is the difference between null value and a zero. Next, if we just have to example, if we just have to show uh, all the employees where bonus is null, bonus column, we have bonus column in the table, correct? Now, example to show the employees whose bonus is null. Okay, how to write the query? We'll just write it as select star from employees where bonus, will use is null function here. Okay, where bonus is null. If we just execute this, you'll get to see all the employee details where bonus column is null. Okay, Understood this? All right. So next, how do we find duplicate records in a table? Duplicate records in a table. Okay, how do we write the query? We'll just write it as select name count of stars. That means we are counting each and every row in a table. That means from employees table, for example. Okay. Next, we'll group by name having count of star greater than 1. Okay. If the count of employees which are grouped by name is greater than 1, this will show the output. Okay. If you just execute this, you will be seeing no details, right? That means there are no duplicates present. Okay. So that is how we we extract duplicate records in a table. We are just counting the rows which is grouped by name. If the value is greater than 1, that will show here. Next question. What is the difference between union and union all? Simple. And union all. First, we'll see what exactly is union. When I'm explaining you this union, I will just show you. Where is it? Here is it. So union is nothing but this returns all the unique values from the table. Okay. For example, we have two tables and we are trying to get all the unique values from there. We can use unique. And this applies for the same table also. Wherever there is unique values, this will show. For example, um, if you just have to show this, before that, what is union all? Then union all is nothing but returns all the values, including duplicates also, right? Union removes duplicates. Union all includes the duplicates, right? Okay. Union, yes, union removes duplicates. Next, union all include duplicates. That is the simple difference between union and union all. If you just have to write an example, I'll just write it as select name from employees. Okay. Union, select department from employees. If we just execute this, you'll get to see all the unique names. Okay. Understood? Clear with this? All right. Next. Next question. Sorry, where is it? Okay. Now, how do you get the second highest salary from the employee table? Okay. Most important question. Second highest salary from the employee table. How do we write the query? We'll just write it as select maximum of salary. We use max aggregate function here and show that as uh, second highest, okay, from employees table where salary is less than. Here I'm using subquery. That means select statement inside another select statement. Select maximum of salary, okay, from employees. This is how we get the second highest salary from employees table. There is some error. Here it is. SELECT. Okay. So what exactly this query is doing now? This is selecting maximum of salary and showing this as second highest from employees table where salary is less than maximum salary. Okay, clear with this? If we just execute this, you'll get the second highest salary, that is 75,000. Okay, right. So next question, what exactly is a foreign key? What is a foreign key? Foreign key is nothing but that is used to link the tables. That means that acts as a link between the tables. A foreign key links records in one table to the primary key in the other table. Okay. Links records in one table to the primary key in the other table. Okay. That is what primary key is. Now, how to declare this foreign key? Sorry, that is what foreign key is, and how to declare this foreign key. We'll just mention any column like this. For example, we want department ID column should be a foreign key. I'll just write it as foreign key of department underscore ID references. Okay, we have to use this references because uh, we are considering two tables, right? References, departments table, department ID. Okay, that means from the employee table department ID, which acts as a primary key, we are just linking that primary key column to the departments table department ID column. Okay, which acts as a primary key, sorry, which acts as a foreign key in the departments table. Clear with this? Yes? All right. So next, the difference between inner join and left join. Okay, we know this already, but again, inner join and left join. What exactly is the difference? Inner join shows only common records, correct? Inner join shows or retrieves only common records. And the left join shows all the common records plus it also shows all the other records in the left table. Okay, so that is the difference between inner join and left join. Next, how do we write a query to count the number of employees in each department? Right now, okay, we'll use left join here. I'll just write it as select departments dot name. That means from the departments table, we are retrieving name column, and I'll just write it as count of employees dot employee underscore ID. We are just counting the number of employee IDs from employees table and show this as number of employees, for example. Okay, now I'll write as from departments table left join employees. That means we are just left joining departments table with the employees table. On is a function that we use, and we need to mention the common column here, right? Departments dot uh, department ID. I think this is a column name. Department. Oh, no. Only ID is the column name from departments table. Next is equal to employees dot department ID. Okay. Now group by departments dot name. So this is how we show count of each employee. count of employees in each department using joins. Okay, there is some error. This one by, if we just execute this, the same question we have answered using having also, right? If you just execute this, you'll get to see for each departments, um, for each department, how many number of employees are present. Okay, this we have done using join. Next. Okay, 14th question. How can you fetch only odd or even rows? Okay, here for fetching odd rows, the query will be, for example, employee ID is the column where we have all the sequential numbers like 1, 2, 3, 4, and so on. We'll use the query like this. Select star from employees table where, okay, which function do we use here? We'll use mod function, okay, where we get the reminder, correct? When we divide a particular employee ID with 2, for example, okay, if we get the reminder as 1, that means employee ID value is a odd number, correct? If we get the reminder 1, the ID is a odd number. If we get the reminder 0 when divided by 2, that means it's a even number, right? So we'll use mod function here, and employee ID comma divide by 2, okay, is equal to 1. That means whenever we get 1 as a reminder, that means it's a odd rows. If we just execute this, you will get all the odd number of rows: 101, 103, 105, 107, and 109. Okay, now how to get even numbers? Even rows. We'll just write the query as like this. Select star from employees where mod of employee ID when divided by 2, it should be equal to 0. If we just execute this, you'll get all the even number of, even rows from the employee ID column, right? So that is how we find odd rows and even rows. Next, it is asking how do you find the maximum salary for each department? Okay, simple thing. We'll use group by function here. Maximum salary per each department. Okay, and the query will be select department ID, comma, maximum of salary. Okay, and show this as max salary from employees table, which is grouped by department ID. Okay, this will give us the maximum salary for each department. If we just execute this, for department ID 1, the maximum salary is 60,000. For second department, the maximum salary is 80,000, right? Now, if we just mention here department name, and this one also department name. Now, if we just execute this, okay, the column name is only name, not department name. I think so. Now, if we just execute this, okay, the column name is not name also. We'll just check that. Select star from employees. What is the department name? Only department, right? So the query will be select star or select department, comma, maximum of salary, and show this as max salary from employees table group by department. Okay, that means for each department we'll get what is the maximum salary. See, for HR department it is 60,000 for IT, 80,000, and similarly for rest of other departments also. Okay, next. How do you find employees who do not belong to any department? Okay,